The moon watches silently over Earth, its pale light cast upon our nights since time immemorial. Ancient peoples spun legends about its origin. One tale speaks of an old man who unearthed a shining object that grew until it escaped into the sky and became the moon. This is the very moon that gazed down on Earth as life first sparkled in our oceans billions of years ago. But the moon has its secrets. Written in its rocks is the record of a spectacular past. Where did the moon come from, and what role has it played in life's story? For generations we could only wonder. Now, bit by bit, we are uncovering the truth, and it is stranger and more profound than we ever imagined. We must cast aside old assumptions. It's time to see the moon in a new light. Lunar rocks are like pages of an ancient history book. When Apollo astronauts brought back samples over 50 years ago, those rocks gave us our first clues to the moon's epic history. Scientists found that the chemical fingerprint of moon rocks is virtually identical to rocks from Earth. It appears the Earth and the moon share a common origin, a violent one. The leading idea for many years was the giant impact hypothesis. It proposes that over 4.5 billion years ago, when Earth was young, a Mars-sized protoplanet, often called Theia, slammed into our early Earth. The colossal impact shattered Theia and tore off a huge chunk of Earth's crust. Earth was left molten and surrounded by a spinning disk of red-hot debris. In time, perhaps a few decades or centuries, that debris coalesced and cooled into a glowing newborn moon orbiting a devastated Earth. This giant impact theory explains a lot: the moon's overall composition and its initial molten state. But it had a major flaw. If a large part of the moon came from the impacting planet Theia, the moon's composition should differ from Earth's. Yet lunar rocks show the same isotopes and elements as Earth's crust, almost like Earth and Moon are twin siblings formed from the same material. How could the moon form from a collision and still be so similar to Earth? Scientists have proposed some bold ideas to resolve this. One dramatic alternative suggests that early Earth might have experienced a massive nuclear explosion in its mantle, a georeactor event that blasted a chunk of Earth into orbit to become the moon. It's an exotic idea, perhaps too exotic, as it's hard to imagine enough radioactive fuel gathering naturally to blow apart a planet. A new perspective, however, is beginning to emerge. Maybe the giant impact did happen, but we misinterpreted what it created. Recent research hints that the impact might have turned Earth into a temporary, bizarre state of matter called a synestia. Essentially, a huge, donut-shaped cloud of vaporized rock spinning in space. In this scenario, the collision completely vaporized Theia and much of Earth, forming a vast, hot torus of molten rock vapor. Within this spinning furnace, droplets and streams of molten material began to condense. The moon grew from magma rain inside the edges of this giant, vaporous swirl that was once Earth. For a time, the infant moon may have been hidden inside Earth's extended vapor atmosphere. Only after the synestia cooled and contracted did the moon emerge, and Earth reformed as a smaller, solid planet. In this vision, Earth and Moon truly share the same material, explaining their twin composition. The synestia hypothesis is still unproven, but it brings us closer to solving the Moon's riddle. Bit by bit, the Moon is yielding its secrets, and there are more surprises. The Moon, long thought dry and barren, may have once had water and even brief periods of a thin atmosphere. In fact, twice in the distant past, around 4 billion and 3.5 billion years ago, lunar volcanoes could have released great clouds of water vapor and gas. temporarily blanketing the moon in a tenuous atmosphere and pooling liquid water on its surface. It's almost unimaginable. An ancient moon with steaming hot springs or even shallow lakes under a sky lit by an enormous infant Earth. Microbes from Earth, hitchhiking on meteorites blasted off our planet, might have been able to take hold in those lunar oases for a short time. If life ever did spark or briefly thrive on the moon, it was only a fleeting chapter. Before long, the moon's interior cooled and its volcanic outgassing ceased. Any precious water on the surface either seeped away into the ground or escaped into space, and the moon returned to being the airless, desolate world we know. Even so, the moon profoundly shaped life on Earth in another way. After the cataclysm of its birth, the moon settled into orbit and began stabilizing Earth's wobbling tilt. This steadying influence prevented extreme climate swings. Without the moon's gravitational pull acting as a brake, Earth might have lurched through wild changes in orientation, triggering chaotic seasons that could thwart the development of complex life. Our moon's steady presence helped Earth maintain a relatively mild, life-friendly climate over billions of years. In a very real sense, we might owe our existence to the moon. Our stories are intertwined. To know the moon's history is to know our own beginnings. Yet many mysteries remain. The moon still holds pages of history we haven't read. We've learned that it's not just a dead rock, but a witness to Earth's formation, a stabilizer of climates, and perhaps a cradle that kept Earth's early life safe. What else could it be hiding? One day, humans will return to the moon and perhaps establish permanent bases. With new tools, we'll dig deeper into its past. Each discovery will not just illuminate the moon's story, but also fill gaps in the grand story of how worlds are made and how life arises. The moon will be waiting for us, as it always has, our ancient companion, glowing quietly with secrets under the endless night. Our journey now carries us beyond the moon, beyond the Earth, into the wider cosmos. For as long as humans have gazed up at the night sky, we have asked a question that grows more urgent as our knowledge expands. Are we alone? We now turn from our moon's familiar face to the countless stars and worlds beyond, seeking answers in that vastness. There are two possibilities, wrote Arthur C. Clarke. Either we are alone in the universe, or we are not. Both are equally terrifying. Across all of time, on all the planets of all the galaxies, have other beings risen, looked at their sky, and wondered as we do. Are we truly alone? Or is Earth just one chapter in an endless cosmic saga of life? The answers lie out there, in distant space, and perhaps in deep time. For the first time in human history, we have tools that can begin to find those answers. At last, the veil is beginning to lift on this greatest of mysteries, and the truth, whatever it may be, is nearly within our reach. The search for life beyond Earth will not only tell us who else might be out there, it will also reveal more about who we are and what our future might be. As we search for life in the universe, we must start by understanding life's beginnings here at home. The complexity of life around us is breathtaking. But how did it come to be? What special ingredients turned a barren young Earth into a living world? Life, we've learned, is a product of chemistry and environment. In essence, we are collections of chemicals, animated by energy under the right conditions. So what are those ideal conditions? First and foremost, you need a source of energy, but not too much. Life is a delicate balance between having enough energy to drive chemical reactions and not so much that those reactions are destroyed as fast as they occur. For a planet, that typically means being at a comfortable distance from a star, soaking in warmth but not roasting. Sunlight powered the early Earth's life chemistry, along with heat bubbling up from within the planet. Other forms of energy can work too. Geothermal heat at the bottom of an ocean, for instance. But whatever the source, energy is the spark that allows atoms to combine and recombine into the complex molecules life requires. Next, you need a diversity of chemical elements. The universe began with mostly hydrogen and helium, wonderful for making stars, but not enough for life. Life needs heavier elements: carbon, oxygen, nitrogen, sulfur, phosphorus, and so on, the stuff of proteins, DNA, and cell membranes. These elements were forged in the hearts of stars and scattered by supernovae. A planet that could host life must be made of this enriched star stuff and gather a variety of elements in its air, water, and rocks for chemistry to play with. Finally, you need a liquid medium where molecules can mingle, bump together, and link up. On Earth, that liquid is water. Liquids occupy a sweet spot. In a gas, molecules fly past each other too fast and rarely stick together. In a solid, molecules are locked rigidly in place. But in a liquid, molecules move just enough to meet and react, forming new compounds. Liquid water, in particular, is amazingly good at dissolving substances and facilitating complex chemistry. It allows molecules to assemble into long chains and intricate structures, yet it's stable enough to give nascent life a fighting chance. So far, water is the only liquid we know for sure can support life's chemistry. But perhaps on other worlds there are alternatives. Liquid methane on Titan, or ammonia-rich mixtures elsewhere. Still, water remains our best guide. So, energy, diverse elements, and liquid water. These are the hallmarks of a life-friendly environment. Where can such Goldilocks conditions be found? Planets are an excellent start. Our own planet, Earth, met all these criteria early in its history. Some 4 billion years ago, Earth was situated at just the right distance from the Sun for water to pool in vast oceans. Volcanoes and geothermal vents provided chemical-rich environments and heat in the depths of those oceans. And the Earth had plenty of heavy elements, courtesy of previous generations of stars, to build organic molecules. In those primordial seas, a miraculous chemistry began. Simple atoms combined into complex molecules, which eventually assembled into the first cells. We still don't know the exact recipe that turned non-life into life. That remains one of the great scientific mysteries. But it likely happened in stages, and it required those key ingredients. At first, life on Earth may have gotten started near submarine hydrothermal vents, places where hot, mineral-laden water spews from the ocean floor. These vents provide both energy, in the form of heat and chemical gradients, and a rich soup of molecules. It's astonishing, but within what Earth's geology would consider an instant after the planet became even remotely habitable, life appears to have taken hold. Some studies suggest life was present on Earth 4.2 billion years ago, almost immediately after the planet cooled from its fiery formation and after the worst of the asteroid bombardment had passed. Conditions back then would seem hellish to us. Volcanoes constantly erupting, meteors raining down, a toxic atmosphere, oceans nearly boiling. Yet life, simple microbes, somehow emerged and endured. Very quickly, Earth's microscopic pioneers spread and adapted. That tells us something hopeful. If life could ignite in such harsh conditions here, maybe it can arise on many other worlds too. Life, once it gains a foothold, is incredibly tenacious and inventive. On Earth today, we find microbes thriving in places previously thought utterly inhospitable. In the driest deserts, in lakes of acid, inside nuclear reactors, under kilometers of rock, and in the crushing black depths of the ocean. Extremophiles, we call them, lovers of the extreme. They show that so long as the three basic requirements are met in some form, life can hang on even in the unlikeliest niches. Earth's story teaches us that life is not a fragile miracle that needs a paradise. It is a fighter that seizes any opportunity. It uses whatever energy and materials it can get. It adapts to heat, cold, radiation, pressure. Life is, within the bounds of physics and chemistry, almost inevitable when conditions allow. This gives us reason to think life might be common in the universe. After all, the ingredients and conditions that gave rise to life here are not unique to Earth. We now know that other planets and moons have water. Organic molecules are found in interstellar space and on comets, and energy abounds in forms like sunlight, geothermal heat, and even tidal flexing from gravity. The cosmos is fertile. After roughly 4 billion years of evolving in isolation, life on Earth has finally gained the ability to look outward for kindred spirits. We have built telescopes and probes, and we have started identifying other worlds where life might exist. Where there is water, there may be life. This rule of thumb guides much of our search. Thus, we are especially interested in exoplanets, planets around other stars, that reside in the habitable zone, where it's not too hot and not too cold, so liquid water could persist on the surface. In the past few decades, our discoveries of such planets have been nothing short of tantalizing. Consider a few examples from the growing catalogue of distant worlds. Kepler-62f is a super-Earth about 1/200 light-years away. It's roughly 40% larger than Earth and likely covered in a global ocean, a true water world. It's older than Earth by a couple billion years. Its star is cooler than our Sun, so Kepler-62f might be on the chilly side. Computer models suggest an average temperature well below freezing if it lacks a thick greenhouse atmosphere. But if it has enough carbon dioxide or other greenhouse gases, it could maintain liquid water. With 7 billion years of time under its belt, who knows what stories its oceans could tell? Another intriguing system is TRAPPIST-1, just 41 light-years distant. This faint red dwarf star has 7 known planets, and astonishingly, 3 or 4 of them are in or near the habitable zone. Take TRAPPIST-1d. It's about 77% the size of Earth and around 7.5 billion years old. Estimates put its equilibrium temperature at roughly 6 degrees, 21 degrees, but that doesn't account for atmospheric warming. It could very well be temperate if it has a decent atmosphere. TRAPPIST-1d might be an ocean world as well. The TRAPPIST planets are so close to one another that an astronaut standing on one could potentially see clouds or continents on the neighbouring planets hanging in the sky. These worlds are extremely intriguing because any life there has had a head start of billions of years on us. However, orbiting a red dwarf has downsides. Such stars often flare violently, which could strip atmospheres and sterilize surfaces. But life might survive underwater or underground, sheltered from the radiation. Even closer to us, a mere 12 light-years away, lies Teegarden b. This Earth-sized planet orbits a quiet red dwarf star. It's very similar to Earth in mass and likely in temperature, possibly around room temperature on its surface if conditions are right. It's about 8 billion years old, nearly twice as old as Earth. If life ever arose on Teegarden b, it could be very ancient and evolved. Because it's so nearby in cosmic terms, Teagarden B is high on the list of planets whose atmospheres we hope to analyze for biosignatures, like oxygen, methane, or other chemicals that might indicate life. We have discovered thousands of exoplanets so far, and we've barely begun. Nature's bounty of worlds is immense. The more we look, the more we find that the galaxy is teeming with planets, big ones, small ones, hot ones, frozen ones, and many in between. Current estimates suggest that perhaps 1 in 5 Sun-like stars has an Earth-sized planet in its habitable zone. And red dwarfs, which are even more common than Sun-like stars, also frequently host small planets. TRAPPIST-1 is just one example. If even a small fraction of those planets are actually habitable, the number of life-friendly worlds is mind-boggling. By one calculation, there could be as many as 50 billion potentially habitable planets in the Milky Way alone. And that's just our one galaxy among billions. If we extend our gaze to the entire observable universe, the number of Earth-like planets is on the order of 100,000, 1E20. It's an unimaginably vast number. To visualize it, imagine an animation where each blink of light represents an Earth-like world. Even blinking multiple times per second, you would be watching the animation for 1 billion years to see a representation of all those planets. Every single one of those worlds could have a unique history. Some dead and barren, others lush and teeming, and many yet to even form in the future. The sheer abundance makes it feel almost inevitable that life has arisen elsewhere. Of course, not all those habitable planets will actually be habitable in practice. Some will turn out to be false positives, worlds that by size and distance seem promising, but have conditions that are lethal. A planet could be in the right zone, but completely airless like the Moon, or have a stifling atmosphere like Venus. Some might be water-rich, but starved of certain crucial elements or energy sources. Others might be periodically bombarded by asteroids, or racked by extreme climate cycles. Habitability is complex. Earth has benefited from many fortunate circumstances beyond just being at a good distance from the Sun. For instance, Earth has a magnetic field that shields us from solar wind, and a relatively stable climate, partially thanks to having giant planets like Jupiter to deflect some comets. A planet could be Earth-like in many ways, but lack a magnetic field, and thus suffer atmospheric erosion from its star's radiation. Or it might be too geologically inactive to recycle nutrients and regulate its climate. There are many ways a planet could turn hostile to life, even if it sits in the coveted habitable zone. Still, life might flourish in places we once thought impossible. We used to insist life required a sun-like star and an Earth clone. Now we know life can endure in darkness and under ice. So moons around giant planets, even far from the warm zone, could harbour subsurface life heated by internal energy. Take Enceladus, a small moon of Saturn. Beneath its icy crust lies a global ocean. We've seen geysers of water shooting out of its south pole, containing organic molecules. Deep in Enceladus's ocean, hydrothermal vents likely exist, just like on early Earth. It has water, organic chemistry, and energy from tidal heating. By earthly standards, it's a prime location for life, despite being a tiny moon over 1 billion kilometers from the Sun. Another example is Titan, Saturn's largest moon. Titan has lakes and rivers, not of water, but of liquid methane and ethane. Its landscape, oddly reminiscent of Earth's, with shorelines and rain, is based on an utterly alien chemistry. If life exists on Titan, it would be methane-based and cold-adapted, operating at... We have no idea if such life is possible, but Titan is a natural laboratory for exotic biochemistry. NASA plans to send a drone called Dragonfly to Titan in the 2030s to explore its dunes and lakes, looking for prebiotic chemistry or even signs of life. And beyond our solar system, for every planet orbiting in the warm habitable zone of a star, there could be dozens of moons orbiting the cold giants on the fringes, kept alive by tidal heating. Some of those exomoons might be Earth-sized and even have atmospheres. The number of potential habitats multiplies tremendously when you consider moons. All this means that the chances of life existing somewhere else look better and better. It might not be on the first Earth twin we find. It could be under ice, or in a cloud, or beneath an exotic sea. Life, if it is a fundamental phenomenon of chemistry, may erupt wherever it gets a decent chance. And given the enormity of planets and moons out there, it will get many chances. So when will we know? Some scientists feel we are on the verge of detecting alien life, at least in microbial form. They point to missions in progress and upcoming ones. Within our own solar system, robots are en route or planned for Mars, the icy moons Europa and Enceladus, and even Titan, all hunting for biosignatures. On Mars, the new rovers are gathering samples that might contain microfossils of ancient Martian life, awaiting return to Earth for analysis. Around distant stars, the James Webb Space Telescope and upcoming observatories are sniffing exoplanet atmospheres for unusual compositions that could indicate life processes, like an abundance of oxygen, or perhaps methane paired with carbon dioxide, in a way hard to explain by geology alone. There is a cautious optimism in the air among astrobiologists. Some have gone on record predicting that evidence of life beyond Earth will be found within the next decade or two. That evidence might be subtle, maybe simply a curious imbalance of gases on a distant world that strongly suggests biology, or it might be more direct, like microscopic fossils in a Martian rock, or living microbes in the dark ocean of Europa. It's hard to overstate how momentous that discovery would be. Even finding a single alien microbe, just one, alive or fossilized, would shout to the cosmos that life is not a freak accident of one planet. It would imply that the universe is biologically fertile, and that life is likely commonplace wherever conditions allow. Imagine that day, humanity waking up to the news that we have detected life beyond Earth. Perhaps it's a microorganism found in the plumes of Enceladus, swimming in its subsurface sea. Suddenly, we would know that life can start twice in one solar system. It's not unique to Earth. Or suppose we identify oxygen and methane on an exoplanet 50 light-years away, gases that together shouldn't coexist without being replenished by life. We'd have strong evidence that something is living on that far-off world, exhaling and metabolizing under an alien sun. We wouldn't know what it looks like, or how complex it is, but we would know it's there. For the first time, we'd be able to point to a star in the sky and say, life is likely on a planet around that star. It's thrilling to think that this could happen in our lifetimes. We stand at a crossroads of discovery, with the tools in hand to perhaps answer one of humanity's oldest questions. How ironic would it be if, after millennia of wondering and centuries of scientific progress, we find out we're not alone, just as we finally have the capability to appreciate the answer. In that sense, we live in a privileged moment, on the cusp of either profound revelation or at least a deeper understanding of our uniqueness. Now, let's contemplate the possibilities that come after discovery. If life is found, the next question will be, what is it like? If it's microbial, perhaps under a microscope we'll see familiar shapes, maybe bacteria-like rods or spheres, or perhaps something utterly new. We'll compare its biochemistry to ours. Does it use DNA and amino acids like Earth life, or something entirely different? The answer will tell us whether life everywhere tends to follow the same basic rules, or if there are many ways to construct a living thing. And what if we detect something more advanced? Say, signs of not just life, but civilization. That remains a far more challenging feat, and so far, despite decades of listening, we haven't heard any alien radio calls. But our searches have been limited. The galaxy is vast, and we've tuned into only a tiny fraction of the possible channels. This brings us to the search for intelligent life, arguably the most fascinating and daunting quest of all. After considering how widespread life might be, one naturally wonders, where are the aliens who perhaps have technology like ours, or far beyond ours? Shouldn't a galaxy filled with life also be filled with signals or other evidence of advanced beings? Yet as of now, we see no indisputable signs, a conundrum famously known as the Fermi paradox. It could be that intelligent life is exceedingly rare, or tends to self-destruct quickly, or maybe it's out there but deliberately keeping quiet, perhaps for safety. Or it could be that we simply haven't been looking long enough, or in the right way. Our efforts like SETI have so far scanned only relatively nearby stars, and mostly for radio broadcasts or laser pulses. We might have missed civilizations using methods of communication or energy that we aren't even aware of yet. Every day, huge radio telescopes sweep the sky for anomalies. Thus far, apart from the occasional intriguing blip, like the famous WOW signal detected in 1977, nothing has definitively shouted technology. But absence of evidence is not evidence of absence. Our instruments and algorithms improve each year. We are now using AI to sift through mountains of cosmic data, looking for patterns that might indicate something artificial. We've even begun searching for technosignatures beyond radio waves, things like unusually strong infrared emissions from a star, which might indicate waste heat from gigantic structures, like the hypothetical Dyson spheres that advanced civilizations could build around stars to harvest energy, or peculiar chemical compositions in exoplanet atmospheres, like industrial pollutants that nature is unlikely to produce on its own. It's entirely possible that within the next few decades, we could detect a signature that hints at alien technology. Imagine finding a planet that shows the spectral fingerprints of chlorofluorocarbons, chemicals that, on Earth, were produced by our industry and do not occur naturally in large amounts. That would raise eyebrows. It could indicate an industry on another world. Or perhaps we observe a star dimming in a way that suggests a colossal, non-natural object is periodically blocking it, as was speculated with the star KIC 8462852, Tabby's star. That case turned out likely to be dust, but it opened our minds to what could be out there. If one day we confirm the existence of an advanced alien civilization, the ramifications would be immense. Unlike finding microbes, which affirms life's commonality, but not necessarily its intelligence, finding another technological society means we are definitively not the only thinking beings to have emerged. It would mean the spark of intelligence, too, can ignite elsewhere, and perhaps we might one day communicate or even meet those distant minds. However, given the distances involved, any conversation would be slow. If the civilization is hundreds of light years away, their signals take centuries to reach us, and ours the same back. So any communication would be like exchanging letters across epochs, hardly a lively chat. Still, the knowledge alone that they exist would profoundly change our perspective. All of humanity's differences and squabbles might seem petty in comparison to the gulf between us and them. Knowing them might unite us. On the other hand, maybe the reason we don't hear others is that civilizations are rare, or usually short-lived. Perhaps the filter that life struggles to pass isn't the origin of life, but the sustainability of advanced life. Maybe many planets teem with microbes and simple creatures, but intelligence is a quirk that doesn't always pay off in the long run. It's sobering to realize that in Earth's long, flourishing biosphere, only one species, us, developed technology capable of reaching out, and we've had that capability for barely a century. We might be an outlier, or we might be pioneers. If we are among the first intelligent species in our galaxy, then the destiny of spreading life and consciousness beyond our home falls to us, if we can survive our own technological adolescence. In that case, our responsibility is enormous. We could become the ancestors of a multitude of life forms and cultures that fill the Milky Way in the distant future. If others came before us and failed, perhaps by self-destruction or environmental ruin, we must learn from those unknown tragedies and ensure we do not meet the same fate. Whether we are first or one of many, the quest to find out is vital. The silence we experience now could be temporary. It might end tomorrow with a discovery, or it might last for centuries. Yet even silence can teach us something. It teaches us humility. In a universe so vast, it is possible no one is close enough to hear us easily. It also teaches us patience and determination to keep searching. So, as we aim our instruments to the sky, we also prepare ourselves for whichever answer comes. If we find we're not alone, we will face the challenge of how to approach another civilization safely and wisely. If we find we are alone, at least in our corner of the universe, then we face a different challenge: to bear the torch of consciousness into the cosmic dark for as long as we can. For now, all we can do is continue exploring, both by listening for signals and by venturing out ourselves. And in the meantime, we can explore the incredible diversity of worlds that exist, which, even devoid of life, have much to teach and inspire us. Let us embark, then, on a different kind of journey, not through time, but through space, to witness some of the astonishing worlds that our instruments have unveiled. We will travel not with rockets, but with imagination, informed by discovery, hopping from star to marvel at what is out there. Picture a starship of the future. Call it Navis 3, a vessel capable of approaching light speed. We step aboard this imaginary craft and set out on a grand tour of alien worlds. Our first destination is beyond the edge of our solar system, where the sun's influence wanes and interstellar space begins. As Navis III departs the familiar planets, we glide through the Kuiper Belt, the vast halo of icy remnants encircling the outer solar system. Among these frozen bodies is Haumea, a dwarf planet shaped like an elongated egg, tumbling end over end through the dark. Haumea spins so rapidly, a day there is under 4 hours, that centrifugal force has stretched it into that odd shape. It's coated with crystalline water ice and has a peculiar red spot on its surface, perhaps a mark left by a past collision. Haumea even boasts a thin ring and 2 tiny moons. Though it's just a speck in the emptiness, Haumea hints that even small worlds can hold surprises. We tip our hat to this bizarre little world and push onward. Navis III accelerates outward. Soon, the sun is just another bright star behind us. We are bound for Alpha Centauri, the nearest star system, a mere 4.3 light-years away. Alpha Centauri is actually a trio, two sun-like stars dancing close together, and a small red dwarf circling them from afar named Proxima Centauri. It is around Proxima Centauri that we find Proxima b, the closest exoplanet to Earth. As our ship nears Proxima Centauri, we encounter a double disk of dust, vast belts of debris akin to our solar system's Kuiper belt, but even more massive. Passing through, grains of ice and rock ping off our shields like fleeting sparks. Then the dim red star itself comes into view, and with it, Proxima b. This world lies in the habitable zone of its faint star, and its mass is only a little greater than Earth's. Whether it's a rocky planet with oceans and air, or a barren, baked rock is still unknown. Proxima b has teased astronomers with hints of what it could be. We descend through what might be an atmosphere. Imagine for a moment that Proxima b is a habitable cousin of Earth. The sky overhead would have a reddish tint under the glow of Proxima Centauri. If there are clouds, they might be painted pink and orange by the dwarf star's light. During the day, the two far-off suns of Alpha Centauri A and B could appear as bright points, like exceptionally brilliant stars. On the surface, gravity is a bit stronger than Earth's, given the planet's higher mass, but not crushing. If there are lakes or seas, perhaps fed by rain under a dim salmon-coloured sky, an explorer could stand at their shore and see our sun as just another tiny star among thousands. Yet Proxima b's reality might be less idyllic. Proxima Centauri frequently erupts in intense stellar flares. Every so often, the sky might flash with high-energy light as the star hurls out a storm of charged particles. Without a strong magnetic field and thick atmosphere, any life on Proxima b's surface would be hard-pressed to survive these bombardments. It could be that any biosphere hides underwater or underground, where the flare's effects are muted. Or perhaps Proxima b is barren, stripped of air and water by eons of radiation. Our instruments have detected that Proxima b likely orbits in synchronous rotation, like the Moon around Earth, meaning one side of the planet always faces the star and the other side is in eternal night. If so, one hemisphere bakes, while the opposite freezes, and only a ring of twilight between might be mild enough for life, if any exists. From Proxima b, we launch probes propelled by powerful lasers, a concept humans are actually considering for future exploration. These probes will continue on to other nearby stars, since our imaginary ship, for now, turns toward new destinations spread across the Milky Way. We have so many wonders to see in our tour. We leapfrog dozens, then hundreds of light years from home. Ahead lies Gliese 436b, a Neptune-sized world unbelievably close to its star. This planet has earned the nickname the Burning Ice Planet. Why? Because even though its dayside temperature reaches a blistering 800 degrees over 400 degrees, it's composed largely of water, but water in a form we rarely encounter. The planet's immense gravity compresses water vapor in its atmosphere into an exotic kind of hot ice. Imagine ice that remains solid despite being red hot. That's Ice 7, which laboratory experiments on Earth have created at extreme pressures. On Gliese 436b, this weird ice forms deep down and it stays solid while the planet's fierce heat tries to melt it. It's a place where fire and ice coexist, a truly alien geology. Gliese 436b is also bleeding. Its star's heat is blasting away its outer atmosphere, creating a tail of gas stretching millions of miles into space. As our ship flies by, we see this gigantic comet-like tail shimmering behind the planet, glowing as starlight scatters through it. The sight is both beautiful and forlorn, a world slowly evaporating. Next, we set course for the famous TRAPPIST-1 system, drawn by the allure of its 7 rocky planets. In our imaginations, we skim over TRAPPIST-1e, one of the central planets in the habitable zone. It's roughly Earth-sized and likely rocky. TRAPPIST-1e could easily have liquid water under the right conditions and is one of the most promising Earth analogues found so far. If TRAPPIST-1e has an atmosphere, perhaps thick with water vapor or clouds, the sky might be a hazy pale blue. With a dim red star, midday would feel like Earth's early evening. The star hangs large in the sky, much larger than our Sun appears from Earth, because TRAPPIST-1e orbits very close to it. The year on TRAPPIST-1e is only about 6 Earth days long. Standing on TRAPPIST-1e's surface, in a protective suit, since we don't yet know the air's composition, an astronaut would be treated to an astonishing view: the other 6 sibling planets. Some would loom as big crescents, clearly discernible disks crossing the sky. They might even show colour, perhaps rusty red for one, bluish white for a water-bearing one, each reflecting the rosy light of their star. Imagine nightfall on TRAPPIST-1e. The nearest companion planet might rise like a huge moon, so close you could make out continents or cloud belts if it has them. Such proximity cuts both ways, of course. It means the planets tug on each other gravitationally, which could cause tidal heating or tidal locking. It also means that if life, or even intelligent beings exist in that system, the distance between their worlds is cosmically tiny, far smaller than between Earth and Mars. A spacefaring civilization could hop from planet to planet within days or weeks. We might whimsically think of TRAPPIST-1 as a miniaturized solar system where the countries are entire planets, reachable in the time it takes us to sail across an ocean. Leaving TRAPPIST-1, we jump to a world with one of the most violent climates ever observed. HD B. At a glance, it's a gorgeous sapphire blue, reminiscent of our own planet. But that inviting colour is deceiving. HD 1189733b is a gas giant that orbits extremely close to its star, a type of planet known as a hot Jupiter. Its blue hue likely comes from high clouds laced with silicate particles. In other words, it rains glass on this planet. And the glass rain isn't a gentle sprinkle, it's propelled by winds blowing at up to 5,400 miles per hour, 2 km/h. These are the fastest planetary winds ever measured, literally tearing the clouds sideways around the globe. On the day side of the planet, temperatures climb above 1,000 degrees. If one could ever stand in that atmosphere, which is impossible, as there is no solid surface and the environment is utterly hostile, the experience would be beyond a nightmare. Hot, dark, lit by a dim, ruddy glow due to atmospheric haze, with glass shards hurtling sideways faster than the speed of sound, and a searing wind howling continuously. We hasten past this planet from hell, grateful our own Earth is a benign haven by comparison. But as terrifying as HD 1189733b is, it's a reminder that the universe creates all kinds of worlds, not just the gentle ones. Now we arrive at a young star system where something marvelous is in progress. Around the star J1407, about 434 light-years away, orbits a very young giant planet, or brown dwarf, unofficially called Super Saturn. Why? Because it has rings. Rings dwarfing those of Saturn, more magnificent than we ever imagined. The ring system is estimated to be hundreds of times larger in diameter than Saturn's, on the order of 120 million kilometers across. If such rings were around Saturn, we on Earth would see them dominating our night sky. Around J1407b, They likely consist of dozens of dense bands with wide gaps between. One of those gaps, astronomers suspect, indicates a moon in the process of formation, carving out a path as it sweeps through the particles. This might be the first observation of moon formation around an exoplanet. En route, we drop a probe to weave through these rings. Up close, the rings would appear as a vast plain of icy and rocky debris, from tiny dust grains to boulders the size of houses, all orbiting in a flat disk. In the glare of the young star, the ice particles glitter. Some clump together under their own gravity, maybe the beginning of new moons. On a nascent moonlet within the rings, the sky would be filled edge to edge by the ring plane, a brilliant, arching band that would make Saturn's view look modest. Over time, millions of years, these rings will likely thin out as material coalesces into moons or falls into the planet. For now, we witness a rare, spectacular phase in a planetary system's life, a scene from our own solar system's youth, perhaps, when Saturn's rings might have been far more massive before condensing into its many moons. Continuing, we direct Navis the 3 toward multi-star systems to see the wonder of binary sunsets. We visit a world in the Kepler-47 system, a circumbinary planet that orbits two suns. Imagine twilight there, two stars of different colours, one golden, one orange-red, dipping below the horizon in unison, casting double shadows across the landscape. On such a planet, the concept of night and day is more complex. Sometimes both suns are up and the day is fiercely bright. At other times, one sun sets while the other still shines, giving an eerie, prolonged glow. And when both set together, the night finally falls with an unusual quickness. One confirmed planet, Kepler-16b, is a Saturn mass world orbiting a pair of stars. It has been dubbed a real-life Tatooine, after Luke Skywalker's home planet with its famous twin sunsets. Kepler-16b itself is likely a gas giant and not habitable, but we can imagine an Earth-like moon around it enjoying the warmth of two suns. In reality, double-star planets challenge life with complicated climate cycles, but they also offer gorgeous skies. A particularly striking real example is GW Orionis, a triple-star system where we've observed a deformed, broken-apart disk of dust, likely torn by the complex gravity of three stars. Within one of the gaps of that warped disk, astronomers suspect a planet is forming. If so, that planet might orbit all three stars at once. The sky from such a world would be truly extraordinary. Depending on its position, it could see three suns rise in a dance of light, maybe aligned in a beautiful triangle or appearing at different times. Sometimes, the stars might eclipse one another, causing unusual drop-offs in daylight. To any beings there, the concept of a day would come with triple the nuance. We now steer our journey toward planets that blur the boundary between worlds and stars. One of the most extreme is Kelt 9b, which orbits a hot blue star 670 light-years away. Kelt 9b holds the record for the hottest known planet. With a dayside temperature around 4,300 degrees Celsius, it's hotter than many stars' surfaces. This giant planet is so intensely heated that molecules in its atmosphere are ripped apart. Atoms of iron and titanium have been detected floating in the air, having evaporated out of the planet's interior. Each evening, as the furious dayside rotates into night, the gas cools slightly, and some of those metals condense into clouds. Imagine gleaming metallic clouds, raining down drops of molten iron or other liquid metals when they cool enough. Then the planet's rotation carries them back to the dayside. They evaporate again, and the cycle repeats. It's a world of metal and fire, not a place hospitable to anything we would call life, but an astonishing forge-like environment. In contrast, consider 55 Cancri E, once speculated to be a diamond planet. It's a rocky super-Earth, about twice Earth's size, orbiting so near its star that its year lasts only 18 hours. Early models of its interior, given its density and composition, suggested it could be rich in carbon, conceivably with a carbon crust or mantle that, under high pressure, might be largely crystalline carbon, diamond. Later studies toned down the diamond hypothesis, but 55 Cancri E remains intriguing. It's tidally locked, roasting on one side at over 2,000 degrees Celsius. The day side probably has lakes or oceans of lava. The night side might be significantly cooler, perhaps cool enough for some minerals to solidify. The planet likely has a thin atmosphere of vaporized rock. Our ship swings by, and we witness a red-orange hemisphere aglow with molten rock, while the dark side is shrouded in blackness. If there were ever a planet to represent Dante's Inferno, 55 Cancri A might be it, burning, broiling, possibly sparkling with graphite or diamond under the surface, but entirely inhospitable. Our next stop is something truly mind-bending, a zombie planet orbiting a pulsar. When massive stars die, they sometimes leave behind pulsars, ultra-dense neutron stars that spin rapidly and emit beams of radiation like cosmic lighthouses. The environment around a pulsar is bathed in intense X-rays and high-energy particles. It's the last place one would expect to find planets. Yet, amazingly, the first exoplanets ever discovered, in 1992, were around a pulsar named PSR B257+12. These planets likely coalesced from the debris of the star's supernova explosion. In essence, planets formed from the ashes of a dead star. We fly to the pulsar B257+12. From a distance, the pulsar looks like a tiny, unbelievably bright point, spinning dozens of times per second. It's surrounded by a thin disk of residual material. 3 known planets circle it. The innermost, Draga, is tiny, about twice the mass of our moon. Further out are 2 super-Earths, named Poltergeist and Phobetor, each 4 times Earth's mass. These names, evoking ghosts, are fitting. These worlds exist in the dangerous, haunted vicinity of a pulsar, where life as we know it would be almost impossible. Constant blasts of radiation sterilize everything. Any atmosphere these planets once had has likely been long stripped away. Their surfaces are likely bare rock, perhaps glassy from irradiation, bathed in a ghostly glow from the pulsar's fierce beams sweeping over them periodically. If you stood on one of these pulsar planets, in a very, very good radiation suit, you'd see a bizarre sky. The pulsar would be a star-like object, but when its beam swept across you, it might actually be visible as a tight, intensely bright flash, like a lighthouse beam hitting you every few milliseconds, flooding the landscape with blue-white gamma rays. The ground would slowly be disintegrating beneath your feet as atoms are knocked out by the radiation. It's a truly alien environment, a planet under the light of a corpse star. And yet, theoretically, even here, life might find bizarre refuges, perhaps deep underground, or in transient moments when conditions allow chemistry to spark. Some scientists have speculated about exotic life that could exist on the terminator of a tidally locked planet around a pulsar, with one side constantly blasted and the other side freezing, but it's extremely speculative and unlikely. However, what these pulsar planets definitively tell us is that planets can form and survive in places we never expected. They give us hope that even in the aftermath of destruction, there can be renewal, worlds rising from the grave of a star. Now, having traversed these extremes, let's step back and grasp the enormity of what we've seen. We visited barely a dozen systems out of potentially billions in our galaxy. And our galaxy is just one of countless others. Our exploration, as epic as it feels, has only touched an infinitesimal portion of the cosmos. We truly have scratched the surface of an endless variety of worlds. Astronomers estimate that there are more planets in the universe than there are grains of sand on all Earth's beaches. We likely can't even imagine the strangest ones. Planets with iron showers, planets with triple sunrises, planets made of ice that's harder than steel, worlds shrouded in clouds of sulfuric acid or encrusted with endless crystals of frozen gases. There are rogue planets wandering interstellar space with no sun at all, cold and lightless, except perhaps for faint glow from internal heat. Whole planets adrift in eternal night. And there will be planets far more hospitable than Earth too. It's quite possible that among all those billions of Earth-like worlds, some are true paradises. Planets slightly larger than Earth, with thick atmospheres, gentle climates, older and more benign stars, perhaps fewer extreme disasters, places where life could thrive in lush diversity far beyond what Earth has seen. Scientists call them super-habitable worlds, worlds that might actually be even better cradles for life than our own. We haven't found a confirmed super-habitable planet yet. It's a tricky concept and criteria are debated, but statistically, they should be out there. For instance, a planet around 1.2 times Earth's size, around a cooler, more stable K-type star, orangish star, slightly smaller than the Sun, with a bit more surface water and a bit more archipelago-style land, might foster biodiversity and stability in climate better than Earth does. One day, we might detect signs of a biosphere on such a world and realize that even Earth was not the pinnacle of habitable conditions. Just one example among many. With this humbling knowledge, we circle back toward our own solar system, carrying treasures of insight. Our tiny blue planet, with its single lovely moon, its diverse life and blue seas, now feels both special and yet part of a vast tapestry. We have peered at other tapestries, some wild with chaos, others exquisite with structure. Earth remains our precious home, but we now see it in the context of a universe overflowing with possibilities. Finally, as we return to Earth orbit in our journey of the mind, let's consider the future, not just of alien worlds, but of life and intelligence, including us, in this grand cosmic arena. The universe has been around for 13.8 billion years. By our best understanding, it will continue for an astronomically longer time into the future. What does that mean for life? Right now, life is enjoying what might be called a cosmic summer, the era of galaxies and stars and planets, when conditions are ripe for biology. This era will not last forever. We touched on this earlier during our deep time excursion. Stars are born and stars die. Over the next few billion years, near home, the changes will be dramatic. In about 1.1 billion years, the sun's increasing brightness will likely render Earth uninhabitable to complex life. Our oceans will start to evaporate. Our atmosphere will turn into a moist greenhouse, and a runaway heating could bake the surface. If there are humans, or our intelligent descendants, a billion years from now, they'll either need to drastically engineer Earth or find a new home. In about 5 billion years, the sun itself will swell into a red giant, possibly engulfing Earth entirely, or at least scorching it to a cinder. Before that happens, perhaps our descendants will move farther out, maybe colonizing the outer solar system, or spreading to nearby stars. It's strange to think that our distant progeny might one day watch the sun expand with solemn wonder, knowing it was the star that nurtured their origin, now transforming into something deadly. After the sun's red giant phase, it will shed its outer layers, briefly creating a beautiful planetary nebula, and then settle down as a white dwarf, a hot, dense ember of a star that will shine for hundreds of billions of years, slowly cooling. The remaining planets, likely just the outer ones if any, will circle that white dwarf in darkness. There is speculation now that even white dwarfs might host habitable zones for a time. If a world is at just the right distance from a cooling white dwarf, it could have decades of mild warmth. But on cosmic timescales, that's fleeting. Some science fiction imagines advanced beings constructing habitats around white dwarfs to eke out a living for trillions of years. Yet, no matter what life does, the star supply will eventually run dry. We talked about how star formation will taper off. In roughly 100 trillion years, the last new star will flicker to life, and the stelliferous era, the age of starlight, will end. The universe will then enter a long, slow decline. Black holes might become the central energy sources as they slowly leak Hawking radiation. There is something poetic and a bit melancholic about this far future. For an unfathomable length of time, things will quiet down. If some form of life or intelligence can persist, perhaps in artificial states, or as collectives around the last energy sources, they would witness a universe growing ever darker, one by one. Galaxies themselves will dissipate as gravitational encounters fling stars off like leaves in autumn. We might wonder, will the story of life just fizzle out in that distant epoch? Or could there be some triumph where intelligence finds a way to survive beyond the end, to escape our universe, or create new ones? Some scientists, like Freeman Dyson, speculated that life could adjust to slow the pace of its thoughts, stretching subjective time to experience more within the dying universe. Others have proposed extremely theoretical means of escaping the heat death, such as tunneling into baby universes or altering physics, ideas firmly in the realm of speculation and likely impossible with any known science. What's clear is that today is precious. We live in a blooming universe. It's neither at the very beginning nor anywhere near the cold end. It's a time where suns shine, planets abound, and life, at least here, can contemplate it all. This is, in a cosmic sense, the springtime of the cosmos. If we are among the first intelligences, then how we act might determine how lush this spring becomes. Perhaps life will spread. If humanity or other species venture to the stars and seed new worlds, either with our own settlements or by helping along indigenous life, we might initiate a great flowering across the galaxy. Millions of years hence, the Milky Way could be teeming with inhabited planets, exchanging knowledge, art, and memories. Perhaps we'd even figure out how to traverse the daunting distances in reasonable time, through cryogenic sleep, generation ships, or breakthroughs in physics that today seem like magic. On the flip side, perhaps life is common and already out there waiting, and in time we'll join a community of civilizations that have been navigating existence for eons. Maybe the silence is temporary and will break once we reach a certain threshold of capability or wisdom, at which point contact is made. Either way, we are participants in a grand story, one still in its early chapters. Our fate is not sealed. It depends on choices we make in the coming centuries, how we handle our planet's resources, how we manage our technological powers, how we treat each other, and remain curious and united in purpose. The very fact that we can contemplate other worlds and the end of the universe means we have a responsibility to use that knowledge wisely. As we conclude this journey, imagine the night sky above once more. Whether you are standing on a city balcony or a quiet hilltop or looking through a window, the stars glow with a steady, gentle light. Some of those stars have planets we've talked about, many we haven't, and countless more we can't even see. Almost every star out there is a sun to someone, to something, perhaps just to barren rocks, but perhaps to living beings, or to life not yet born. The universe is fertile beyond comprehension, and will continue to create and eventually retire worlds without end. We return to Earth, our beautiful home, a pale blue dot in an ocean of darkness, yet carrying the warmth of billions of lives, dreams, and the only place we know, with music and chocolate and laughter. How fortunate we are to have been born here, now, able to explore in mind so many wonders, and how important it is to protect this cradle, even as we reach for the stars. One day, human footsteps, or the tracks of our robots and probes, will press into the alien soils of another world. Perhaps in our solar system first, dusty Mars, or the icy crust of Europa, and later, on planets around other suns. When that happens, it will fulfill a destiny implicit in life from the start: to expand, to seek, to know. Life's longing for the stars might even ensure its survival, giving us new homes long after Earth is gone. In doing so, we, or our descendants, will carry the legacy of Earth life outward, giving some meaning to the brief, bright window of time we were given. So, as this narrative draws to a close, picture the cosmic ocean stretching out, full of distant lights. We stand at its shore, feeling small but eager. Beyond tomorrow's horizon lies everything: new discoveries, new dangers, and wonders beyond our imagination. We will face them with the same spirit that led us to climb mountains and cross oceans, a spirit ingrained in life itself to push boundaries. In the gentle darkness of an earthly night, under the ancient light of the Milky Way, we can sense both our fragility and our potential. The universe may be mysterious and immense, but we are part of it, made of its atoms, powered by its starlight, able to ponder its depths. In that sense, we are not separate from the cosmos at all. We are a way for the cosmos to know itself. Our journey beyond tomorrow is just beginning. With each generation, we step a little further into the unknown, voyagers on a tiny world with hearts and minds big enough to encompass the galaxy. Let us continue that voyage with wonder, with care, and with gratitude for the privilege. We end now, but the story goes on. In you, in me, in every inquisitive mind, and in every star that will shine tomorrow night. Look up and feel the connection. The cosmos is home, and we have only just started to explore its endless possibilities. The future, as vast as the stars, awaits. Beyond the edge of our solar system lies the true abyss of interstellar space. The distance to even the nearest star is almost beyond comprehension. Our closest stellar neighbour, the Proxima Centauri system, is over 4 light-years away. That's about 40 trillion kilometres. Even a beam of light, the fastest thing in the universe, takes more than 4 years to journey from here to there. By comparison, our fastest spacecraft would take tens of thousands of years to cover that gulf. The stars in the night sky may look close together, but in reality, they are islands separated by unimaginable oceans of emptiness. Yet the dream of travel to other stars endures. For generations, we have gazed up and wondered what it would take to bridge those vast distances. In science fiction tales, starships whisk across the galaxy at fantastic speeds. In the real world, engineers and visionaries are gradually charting a path toward the stars, one difficult step at a time. The challenge is formidable. How can we send a vessel, and perhaps people, across light years of space within a reasonable time? Current rockets, which sent astronauts to the moon and probes to the outer planets, are far too slow for interstellar voyages. A probe like Voyager 1, sailing outwards since 1977, would need 70 millennia to reach the nearest star. To cross the interstellar void, we will require new methods of propulsion and a willingness to undertake journeys lasting decades, centuries, or longer. One imagined solution is the generation ship, a self-contained world traveling through the darkness between stars. On a generation ship, no one person would complete the voyage. Instead, the original crew would live out their lives on board, and it would be their descendants, born in transit, who eventually arrive at the destination. Such a spacecraft might be a massive rotating habitat, providing artificial gravity and an Earth-like environment to support families for multiple generations. Life on a generation ship would be both hopeful and challenging. Entire communities cultivating gardens under alien constellations, children growing up knowing nothing but the ship as their home, and a promise that their grandchildren or great-grandchildren might set foot on a new world. It is a poignant concept, a journey whose end those who embark will never see, undertaken for the sake of the future. Another approach often envisioned is to somehow sleep through the voyage. In countless novels and films, crews enter cryogenic slumber or suspended animation, bypassing years of travel as if taking a long nap among the stars. Upon arrival, they awake to begin life anew, light years from where they started. In reality, we do not yet know how to safely put humans into such deep hibernation. Medical science has made small strides, lowering body temperatures in certain medical procedures, for instance, but the kind of long, dreamless stasis required for interstellar travel remains speculative. Still, researchers study hibernating animals like bears and squirrels, hoping to unlock nature's secrets of prolonged sleep. If one day astronauts could sleep away years, it might make the psychological burden of interstellar journeys much easier to bear. Of course, shortening the trip itself is another solution, one that leads to developing faster spacecraft. To reach another star in a human lifetime, a ship must travel an appreciable fraction of light speed. Achieving even 10 or 20% of light speed would be an astounding leap from today's technology. Traditional chemical rockets are far too weak for that task. Their fuel efficiency is insufficient to accelerate to such incredible velocities. Instead, scientists look to more exotic propulsion. One promising avenue is nuclear power. Nuclear rocket engines could provide far greater thrust than chemical rockets. In theory, a nuclear pulse engine, an idea studied in Project Orion in the 1960s, could propel a spaceship by detonating a series of small nuclear explosions behind it, effectively pushing it forward. Such a method might drive a robust spacecraft to very high speeds, although the engineering challenges and dangers would be enormous. Later concepts involve nuclear fusion, the same process that powers the stars. A fusion-powered engine could, if perfected, offer a continuous high-speed push, perhaps reaching a few percent of light speed. There was also Project Daedalus in the 1970s, a design for an uncrewed probe that would use fusion fuel pellets to accelerate towards Barnard's star. Daedalus never flew, but its plans suggested we could potentially send a probe to another star within a human lifespan. Even more extreme is the idea of using antimatter. Matter and antimatter annihilate in a burst of energy far beyond any chemical explosion. An antimatter rocket, in principle, could provide the ultimate efficiency in propulsion, converting mass to energy at an incredible rate. Just a few grams of antimatter reacting with matter could release as much energy as tons of conventional fuel. If we could produce and store enough antimatter safely, a starship might sprint across light years in decades rather than millennia. At present, antimatter is exceedingly rare and expensive to create in laboratories, but in the far future, who knows what might be possible. Another revolutionary idea is to dispense with carrying all the fuel on board and instead push a spacecraft using external energy. This is the concept behind light sails and laser propulsion. Imagine a spacecraft with a giant reflective sail unfurled in space. Just as a sailboat is pushed by the wind, a light sail could be pushed by beams of light or lasers. A powerful laser array on Earth or in space could shine on the sail, driving the spacecraft forward with constant pressure. Because the craft wouldn't need to carry heavy fuel, it could potentially reach enormous speeds. A real initiative named Breakthrough Starshot has proposed sending tiny probes attached to light sails to the Alpha Centauri system. The idea is to use thousands of high-powered lasers acting in unison to accelerate a wafer-thin probe to perhaps 20% of the speed of light. At such speed, the probe could fly past Proxima Centauri and its planet in around 20 to 30 years. It's an exciting plan, though incredibly challenging. The technology to precisely aim and coordinate those lasers, and to build a sail and probe that can survive the acceleration, is still in development. While these microprobes would be far too small to carry humans, the concept paves the way for future advances. Perhaps one day, larger craft might ride laser beams, or even the sun's radiation pressure on giant sails, crossing interstellar space without a drop of onboard fuel. As we dream of faster ships, we also encounter the limits set by physics. According to Einstein's theory of relativity, no ordinary object can exceed the speed of light. This is a hard speed limit woven into the fabric of the universe. However, there are a few loopholes that tantalize the imagination. One is the idea of the warp drive, a concept that gained fame through science fiction but has been discussed seriously in theoretical physics. A warp drive wouldn't move a ship faster than light in the conventional sense. Instead, it would distort space-time itself, contracting space in front of the ship and expanding it behind, effectively moving the ship without it locally breaking the speed of light. In theory, this could allow a craft to reach distant stars in a matter of weeks or months instead of years, all without violating relativity, because it's the space around the ship that's moving. A Mexican physicist, Miguel Alcubierre, outlined a mathematical model for such a drive in the 1990s, but it required vast amounts of negative energy or mass, something not known to exist in usable form. While a true warp drive remains purely hypothetical, just the notion that space might be manipulated offers a glimmer of hope that faster-than-light travel isn't entirely out of the question. Another speculative shortcut is the wormhole, a tunnel through space and time, connecting two distant points. If wormholes exist and could be stabilized, they might allow instantaneous travel between star systems, like stepping through a doorway. Wormholes appear in our physics equations as possibilities, but no evidence of a naturally occurring wormhole has ever been found, and creating one would demand energies and technologies far beyond our grasp. Still, the concept fires the imagination. Picture entering a shimmering portal near Earth and emerging instantly orbiting a planet countless light years away. For now, such visions belong to the realm of conjecture and fantasy. The universe might have shortcuts like these, or it might not. Until we can test these ideas, the only certain path to the stars is the slow, methodical one, bound by the speed of light. If we must travel below light speed, then time becomes a critical factor. A voyage to another star could last many years, so how time passes is very important. Interestingly, for those on a fast-moving ship, time itself would slow relative to people left behind on Earth. A strange but true effect of high-speed travel known as time dilation. If a spaceship could somehow accelerate to, say, half the speed of light or more, the crew might experience the journey's duration as less than it would appear to folks at home. For example, a trip that seems to take decades to observers on Earth might feel shorter for the travelers. In an extreme case, if humans undertook a round-trip journey to the center of our galaxy at near light speed, thousands of years would pass on Earth, but the crew might only feel a few decades. They would return to find a distant future world. This time-twisting consequence of relativity is both wondrous and poignant. It offers a form of one-way time travel to the future. However, it also means interstellar explorers could become untethered from everyone they left behind, separated not only by space, but by deep gulfs of time. The practical challenges of crossing the interstellar void are as daunting as they are fascinating. Beyond propulsion and time, there are hazards in the dark between stars. Space is not completely empty. Thin wisps of gas and dust float in the interstellar medium. Hitting even a tiny grain of dust at an immense speed can cause serious damage to a ship. Engineers have considered protective shields for starships, perhaps a thick prow or an electromagnetic field to deflect charged particles. Radiation is another peril. Outside the protective bubble of our sun's heliosphere, cosmic rays and high-energy particles zip through space, posing risks to travelers over long durations. There are also psychological and social challenges. A crew confined in a metal vessel for years, isolated from Earth, would need great resilience and unity. They would see the same faces each day and watch the stars barely change position as months and years pass. Maintaining hope and purpose during the long night of interstellar transit would be essential. And yet, despite all these challenges, the dream remains alive. Humanity's urge to explore is a powerful force. Already, robotic pioneers have made tiny first steps. Voyager 1 and 2 have slipped into interstellar space, becoming our silent ambassadors to the cosmos. We have detected planets around other stars, thousands of them, and we know that some reside in the comfortable warmth of their sun's habitable zone, where liquid water might exist. The nearest such world we know of orbits Proxima Centauri, tantalizingly close on the cosmic scale. We can imagine, perhaps centuries from now, a brave crew embarking on a voyage to that little planet, which we have named Proxima b. They might depart, knowing they will never see Earth again, setting their course by the distant light of another sun. Generations later, their descendants or successors could wake up to a new dawn in orbit around an alien planet, finally bridging the interstellar gulf that once seemed unbridgeable. Crossing the interstellar void would be an achievement unlike any before it, a testament to curiosity, perseverance, and the longing for new horizons. As we imagine that journey, we feel both the enormity of the challenge and the excitement of the possibilities. To travel between the stars is to step into a truly vast unknown, leaving the safety of our familiar solar harbor and venturing out onto the cosmic ocean. It is the ultimate voyage of discovery. And if one day we find a way, through powerful engines, ingenious technology, or sheer patience across generations, the moment a human craft finally arrives at another star will be a milestone for our species. The dark space between suns will no longer be an impassable void, but a sea we have learned to sail. Humanity will have become, in a very real sense, an interstellar species. If and when that day comes, and we set foot on a world circling a distant sun, a new chapter of the human story will begin. The journey through space may have taken decades or centuries, but at last we would stand under an alien sky, the light of another star warming our faces. What comes next? After the long voyage, how would we make our home on a new and possibly strange world? The dream of interstellar travel is intertwined with another grand vision, not just to visit other worlds, but to live on them. The challenge of reaching a new planet is only the beginning. Once there, we would have to find ways to survive and flourish. How might we transform distant planets into places like home? That question leads us to the art of shaping new Earths among the stars. A lone explorer sets foot on the rust-coloured soil of Mars. Above, a pale sun shines through a thin, dusty sky. The air is bitterly cold and almost without oxygen, not a place a human could survive outside a protective suit. And yet, in this stark alien desert, the seeds of a new home might one day take root. The idea of terraforming is to transform such a barren world into an environment where people could walk freely under an open sky. It is the ultimate gardening project on a planetary scale, turning a foreign planet into a second Earth. Terraforming begins with understanding a planet's conditions and what must be changed. In the case of Mars, the challenges are numerous. Mars is a frozen, dry world with a very thin atmosphere, mostly carbon dioxide, and almost no liquid water on the surface. Its atmospheric pressure is so low that liquid water would quickly boil or freeze. The temperature on a Martian afternoon near the equator might just rise above freezing in the sun, but nights and winters plunge far below zero. To make Mars habitable, we would need to warm the planet and thicken its atmosphere substantially. Scientists have proposed many methods. One idea is to release greenhouse gases. For instance, factories could pump out potent heat-trapping compounds, or dark dust could be spread on the polar ice caps to encourage them to melt. As the polar ice releases carbon dioxide that is currently trapped as dry ice, the atmosphere would grow thicker, and the added CO2 could amplify a warming greenhouse effect. With more heat, frozen water buried in the soil or locked in ice caps would melt and form rivers, lakes, and perhaps shallow seas again. As the planet warms and water begins to flow, we could introduce hardy life forms to kickstart an ecosystem. Perhaps we would begin with simple organisms like algae, lichens, or bacteria engineered to survive in the Martian environment. These pioneers could help produce oxygen and further modify the soil. Over decades and centuries, as conditions improve, more complex plants might be sown in the Martian soil. Tough grasses and shrubs at first, slowly giving way to trees as the soil gains nutrients. We can picture a future Mars slowly turning green in patches, with valleys of red rock gradually sprouting with moss and lichen, and later, small forests in sheltered craters. The sky, once a dusty orange, would fade toward blue as the air thickens and fills with clouds. Rain might fall on Mars for the first time in billions of years, filling new rivers. It would be an incredibly gradual transformation, perhaps taking many generations. But bit by bit, the red planet could bloom with life. There are immense technical hurdles to overcome. Mars has no global magnetic field, meaning its atmosphere is vulnerable to being stripped away by the solar wind. If we painstakingly create a thick atmosphere, the sun's constant stream of charged particles could gradually erode it again over time. To counter this, future engineers might deploy a solution beyond anything we've done before. For example, placing a powerful magnetic shield in space at Mars's L1 point, where it would deflect the solar wind and protect the planet's atmosphere. This concept has been suggested by NASA scientists. And while it's purely theoretical right now, it illustrates the kind of creative engineering that terraforming might require. Additionally, Mars's gravity is only about 1/3 of Earth's, which means even if we thicken the air, it will always tend to escape to space faster than on Earth. We might need ongoing efforts to replenish or retain the atmosphere. Terraforming a planet isn't a one-time project. It could require constant maintenance and adjustments, a bit like tending a garden that could revert to wild conditions without care. Beyond Mars, humans have imagined terraforming other worlds in our solar system, though these present even greater challenges. Venus, for example, is in some ways the opposite of Mars, a hellishly hot world with an atmosphere that is far too thick. The surface of Venus is hotter than an oven, hot enough to melt lead, and its sky is choked with clouds of sulfuric acid. To make Venus livable, one would need to cool the planet drastically and remove most of its heavy carbon dioxide atmosphere. Some have suggested using giant space mirrors or shades to block sunlight and cool Venus down. Others imagine seeding the upper atmosphere with special microorganisms or chemicals that could convert carbon dioxide into solid compounds or precipitate it out. It might even be conceivable to bombard Venus with ice-rich comets or asteroids, adding water and causing chemical reactions that lock away carbon. These ideas are speculative in the extreme. Terraforming Venus could be a task of millennia, if it is possible at all. Still, it's a fascinating thought experiment. Turning the morning star, which today is a toxic pressure cooker, into a verdant twin of Earth with gentle blue skies and calm oceans. Still, it is a fascinating thought experiment. Turning the morning star into a verdant twin of Earth with gentle blue skies and calm oceans. For worlds beyond our solar system, terraforming might also be a goal if we find planets that are nearly habitable, but just need a push toward Earth-like conditions. Perhaps one day, a starship arrives at an Earth-sized planet that has breathable air but is a bit too cold, or one that has life only in primitive form, and human settlers decide to assist in creating a richer biosphere. The basic principles would remain the same. Adjust the atmosphere, temperature, and water until the planet falls into a comfortable balance. We might deploy fleets of automated machines to begin altering a planet's environment years or decades before people ever set foot there. By the time humans arrive, the world would already be on its way to becoming a second Earth. It's a bold vision, raising many questions about ethics and practicality, but it underscores humanity's long-term hope to spread life's green domain across the galaxy. Of course, colonizing new worlds won't wait until full terraforming is complete. The first settlers on Mars, or any other planet, will likely live in habitats that shield them from the harsh environment. Picture the early Mars base. Clusters of domed greenhouses and living quarters sealed against the thin air, with astronauts tending crops inside under artificial lights, while outside the wind blows cold dust across the landscape. These pioneers will bring with them the essence of Earth, seeds, microbes, and the knowledge of generations, and they will gradually learn to use local resources to become self-sufficient. Water can be extracted from ice beneath the soil. Bricks can be baked from Martian regolith to build shelters. Over time, a small base could grow into a village, and then into a town, all under pressurized domes or dug into hillsides for radiation protection. Long before Mars is ever fully terraformed, it could have thriving settlements where human life takes hold in pockets of safety. These pioneers would carry the spirit of Earth to a new world. Adapting ourselves and our habitats to an alien planet is in many ways the precursor to terraforming. It's sometimes called para-terraforming, or building world houses, essentially creating large enclosed spaces on the surface where Earth-like conditions are maintained. Imagine a vast, transparent dome covering an entire Martian valley, with air pumped in and kept warm, sunlight filtered to levels suitable for plants, and inside, a growing Earth-style ecosystem. Within such a dome, tens of thousands of people could eventually live, farm, and walk around without spacesuits, even while the world outside remains cold and unbreathable. These small Earths within bubbles could dot the landscape as humanity slowly reaches outward. Over centuries, as technology advances, those protective bubbles might expand and merge, gradually converting more of the planet's surface into shirt-sleeve environments. In a sense, terraforming could start local, with contained havens, and then broaden as our confidence and knowledge grow. Colonization might not be limited to planets at all. We could build free-floating space habitats that are essentially artificial worlds, enormous rotating cylinders or rings that spin to create artificial gravity and are filled with air, water, soil, and life. Such constructs, orbiting a planet or stationed in the space between planets, would be new Earths made by human hands. However, there is something poetic and deep in the idea of rejuvenating a barren planet like Mars, of stepping onto a world that was once thought dead and hearing the rustle of wind through planted forests, or the trickle of flowing streams under an alien sun. The path to shaping new Earths will likely be a long one. It may take hundreds, even thousands of years of concerted effort to see a true transformation. No one generation would complete the task. It would be begun by our distant descendants and carried forward by many more. They would pass down the dream like a baton through time, each age of colonists contributing, knowing they might not live to see Mars fully green or a sunset through a breathable sky. And yet, step by step, day by day, the world would change. Perhaps a child born on Mars a few centuries from now might play in a meadow without needing a helmet, breathing air that feels as natural to them as Earth's does to us. Such a future is difficult to grasp in its entirety, but it speaks to the pioneering spirit of our species. As we consider terraforming and colonization, we must also remember that any world we touch could have its own destinies, or even its own life. If Mars, or another planet, harbors indigenous microorganisms, we would face ethical questions. Do we have the right to remake a world that already hosts its own life, however simple? Perhaps, before launching any grand terraforming plans, humans will carefully search for existing life and choose to protect it if found. In one scenario, we might find Mars lifeless and proceed freely to reshape it. In another, we might discover a biosphere clinging beneath the ice of a moon like Europa and decide to leave that world untouched, a kind of galactic park, altering nothing. Our expansion into the cosmos will require wisdom and humility to match our ambition. Still, the allure of creating a new Earth from an alien world is strong. It represents hope, the promise that we can not only travel to distant planets, but truly make them our home. Each colony, each terraformed sky, would be a declaration that life can bloom in places once thought inhospitable. It would also be a safeguard for our survival. As a multi-planet species, humanity would be less vulnerable to any single planetary catastrophe. In a universe filled with worlds, why should life remain confined to one? As we spread out, we carry the legacy of Earth with us. Not just our genes and cultures, but our trees, our flowers, our very breath. In time, perhaps, there will be many human worlds orbiting different suns, each with its own character, shaped both by its native environment and by the influence of its settlers. One might have orange skies and shallow seas where adapted earthfish swim. Another might have purple forests under a dim red sun, because our transplanted plant life evolved new colours in response to alien sunlight. Our descendants could travel between these worlds, experiencing the delight of different skies and landscapes, all distant echoes of Earth, yet unique in their own ways. Through terraforming and colonization, we extend the essence of Earth, life in its myriad forms, far beyond its birthplace. Today, these ideas remain largely theoretical. The first steps are already being planned. Robotic probes are scouting Mars's resources, and enthusiasts talk of terraforming kits, packages of machines and microbes that might jumpstart a planetary makeover. While the reality of fully terraforming a planet lies far in the future, in a sense the process has begun in our minds and laboratories. Each greenhouse we set up on Mars, each experiment in sustaining a closed ecosystem in space, is a small rehearsal for the grander symphony to come. From crossing the void between stars to cultivating new Earths under alien skies, our journey continually transforms both ourselves and the cosmos around us. And if one day Mars is green and Proxima b has a thriving human outpost, we will have proven that life can be a cosmic force of creation, not just confined to one fragile world. The notion of home will expand to include many worlds. Yet, as we shape planets to suit us, we might also find that those planets shape us in return, physically, culturally, and spiritually. Life on a terraformed Mars, for instance, would not be exactly life on Earth. The lower gravity, the different day-night cycle, the coppery light, all will influence the new society that grows there. Over generations, colonists might even start to think of themselves as Martians in their own right, connected to Earth by heritage, but bonded to their new world by love and necessity. Far beyond the worlds humanity might remake for itself, countless alien ecosystems may already flourish in the cosmic wild. Life, if it exists elsewhere, could take forms stranger than any earthly animal or plant. On some distant exoplanet, under the glow of unfamiliar stars, there might be creatures adapted to conditions we can barely imagine. Nature is inventive, and wherever there is a niche, some source of energy, some stable environment, life has a chance to emerge and fill it. On Earth, we find life in extreme places. Microbes thriving in boiling hot springs, tiny creatures alive in Antarctic ice, and worms and crustaceans clustered around seafloor volcanic vents where sunlight never reaches. These hardy organisms teach us that life can be astonishingly resilient and adaptable. So picture the vast variety of environments across the galaxy, from planets with searing atmospheres to moons locked in eternal ice, and consider how life might adapt to each. Imagine a planet orbiting a dim red dwarf star. The star's light is feeble and ruddy, casting a perpetual dusk over the planet's surface. To us, it might look like a twilight world bathed in deep crimson hues. Yet perhaps forests of alien plants carpet this world, their foliage almost black to soak up every bit of the weak sunlight. Under the thick canopy, strange animals move in the gloom. Without bright light, some creatures may have evolved to sense their surroundings in other ways, perhaps through echoes, like bats, or with long, feathery antennae that pick up chemical traces on the breeze. In the silence of a red twilight forest, you might see flickers of bioluminescent glow, insect-like beings communicating with pulses of blue-green light or luring prey with a soft, ethereal radiance. Now envision a different world, one that races around a brilliant blue-white star. Daytime there is harsh, flooded with intense ultraviolet light. To survive, life might have become armor-plated or reflective. Picture broad-leaved plants with shiny, mirror-like surfaces that deflect excess sunlight, shimmering as they turn their reflective faces toward their fierce sun. The animals on this world might wear natural sunscreens, glossy, metallic scales or shells, to avoid being seared by radiation. Some could be burrowers, staying underground during the blistering day and emerging in the relative cool of twilight. Others might thrive in the star's glare by having multiple translucent eyelids or filters that shield their sensitive eyes. On the shores of an alien ocean, perhaps a creature like a great silver-shelled turtle drags itself into the surf, its protective carapace glinting under a sky of unfamiliar constellations. Consider a planet that shows the same face to its star at all times, one hemisphere in perpetual daylight, the other in endless night. In the blazing dayside, perhaps nothing survives the inferno. On the frozen dark side, ice stretches for miles. But at the narrow boundary between day and night, a land of eternal sunset might exist where temperatures are mild. In that twilight ring, life could eke out an existence in perpetual dawn. Strange organisms might migrate gradually to stay within this zone of dusky light, following the terminator line between light and dark. They might endure constant winds that rush from the hot side to the cold, evolving sturdy forms to withstand these gales. Low-growing, hardy plants clinging to the ground, and creatures that burrow or huddle in crags to shelter from the howling air currents. Their entire world would be a delicate balancing act between fire and ice, with life thriving in the thin margin of twilight that separates two extremes. Consider also the giants of our galaxy, the gas giant planets with their banded clouds and eternal storms. These might seem like unlikely abodes for life, with no solid ground to walk on. But scientists have speculated that even in the swirling atmosphere of a Jupiter-like world, life could potentially exist. It wouldn't be land-based, of course. Instead, one could imagine enormous floating organisms, buoyed by vast gas bladders like living zeppelins, drifting on the wind currents of their world. In the upper layers of a gas giant's atmosphere, conditions might be mild enough for complex chemistry to churn and for life to gain a foothold. These sky-bound life forms might feed on aerosol nutrients or sunlight, harvesting energy through some alien form of photosynthesis or chemical reaction. Others might thrive as smaller, kite-like predators gliding between them. Perhaps translucent beings like great jellyfish in the air, their trailing tentacles catching tiny drifting organisms in the dense atmosphere. It's an almost whimsical vision. Creatures living their entire lives in mid-air, never touching ground. But it's not beyond the realm of possibility in the cosmic wild. Still, we can imagine the scene. High above the vividly striped clouds of a gas giant, a colossal, balloon-like creature with mottled patterns slowly ascends, basking in the sunshine filtering down, while nearby, a school of smaller fluttering organisms dances around it. Thunderstorms flash light in the distance, illuminating these aerial creatures in brief, ghostly silhouettes. In a universe so vast, life may find a way even in these lofty and turbulent skies. Then there are the worlds of perpetual ice and ocean. In our own solar system, moons like Europa and Enceladus hide global oceans beneath their frozen crusts. On these and similar worlds, any life would know a very different reality from ours. Imagine an ocean planet cloaked in ice, its surface locked in eternal night. Beneath the ice, in the inky black water, volcanic vents on the seabed provide warmth and nutrients. Around these vents, perhaps alien communities thrive, much as certain deep-sea creatures do on Earth. Think of tube-like worms or strange crustaceans, but maybe tinted in iridescent colours, clustered around a vent that glows faintly with heat. Their bodies might have never known light, so they could be eyeless, navigating by touch or by sensing slight chemical gradients in the water. Strange, pale fish or squid-like beings might glide in the darkness, using sonar-like pulses to map their world in sound. They could have slow metabolisms, living in an environment where change is measured in geological timespans. The water above them is capped by kilometers of ice, insulating their ocean and forever concealing the sky. If we one day drill through the crust of such a moon and send a probe into that dark ocean, who knows what life forms might drift up, curious about the sudden intrusion of light from above. Perhaps translucent ribbon-like swimmers, as graceful as jellyfish, might circle our submersible, sensing its warmth or electric hum. We would peer through the camera feed at alien life, swimming in its natural habitat. Life that never saw a star until our lights appeared in their eternal night. Life might not even require a warm, Earth-like climate at all. Consider Saturn's moon Titan, an icy world with lakes of liquid methane and ethane. On Titan, the temperature is far below freezing, and water exists only as rock-hard ice. Yet some scientists have speculated about the possibility of methane life, organisms that might metabolize using liquid methane instead of water. Such life, if it exists, would be built from very different chemistry. We might imagine something like a microbial film on the shores of Titan's frigid hydrocarbon lakes, slowly consuming and excreting chemicals in the oily liquid. Perhaps simple slug-like creatures inch along Titan's cold beaches, their bodies using antifreeze-like chemistry to remain flexible in the cryogenic temperatures. They might breathe hydrogen and inhale nutrients from organic-rich mud, their metabolism far slower than life's pace on Earth. This scenario is highly speculative, but it reminds us that life might find a way even in environments we would consider utterly hostile. The recipe for biology could have many variations, and nature may experiment with all of them across the cosmos. The possibilities for alien life forms are as vast as the galaxy itself. Some worlds might host only tiny microbes, simple single-celled organisms invisible to the eye, yet fundamentally reshaping their environment over eons. Other planets might be lush gardens, teeming with an alien equivalent of plants and animals in endless variations. There could be flying beasts under skies of colours we've never seen, or intelligent ocean dwellers building intricate coral-like cities in the depths. The diversity of life on Earth, from the deepest oceans to the driest deserts, is breathtaking. And Earth is just one data point. With billions of planets in our galaxy, each with its own conditions and history, life's forms could exceed our wildest dreams in their variety. One thing seems likely: any extraterrestrial life will be well suited to its home world. Just as a polar bear is perfectly adapted to Arctic ice and a camel to the desert, alien life will have adapted to the peculiarities of its environment. On a high-gravity planet, for instance, land animals might be low-slung and powerfully built to move under the weight of a stronger gravitational pull. With thick, sturdy legs and compact bodies, they could avoid being crushed by their own mass. Birds or flying creatures on such a world might be rare or non-existent, since flight would be much harder under heavy gravity. Only creatures with immense wingspans and exceptional strength might manage to get airborne. Conversely, on a moon or planet with weak gravity, creatures might grow taller and more delicate, reaching heights that would be impossible on Earth. In a light gravity environment, even large animals might bound along in great leaps or glide with wing-like membranes, covering vast distances with each gentle push off the ground. Take those same creatures and put them on Earth, and they might lumber awkwardly, weighed down by our stronger pull. But at home, under gentle gravity, they could be graceful giants or soaring flyers, riding the winds with ease. An alien biosphere might also surprise us with senses and abilities beyond our experience. Consider communication. While we rely on sound and sight, life on a dark world might evolve to communicate through electrical signals or magnetic fields. Some earthly sharks can detect faint electric fields given off by their prey. An alien animal might use a refined version of that sense to speak in an electrical language, sending pulses that others of its kind pick up with specialized organs. In the dense atmosphere of a foggy planet, creatures might converse with low-frequency vibrations that travel through thick air or the ground, a kind of infrasonic song that can be felt as much as heard. Patterns of bioluminescent light could serve as language too. Imagine creatures in a deep ocean, flashing intricate sequences of colors along their bodies to convey emotion or warnings, turning an entire reef into a silent symphony of blinking lights. As we search the skies for signs of life, we often look for things that remind us of home. Oxygen, in an atmosphere, for example, as a possible signature of plant-like organisms performing photosynthesis. We have even detected intriguing hints, such as unusual chemical mixes in the atmospheres of distant planets, that make us wonder if biology could be at work there. But until we can actually visit or receive a clear signal, much of this remains guesswork. Still, it's delightful to let the mind wander across the cosmos, populating each new world we imagine with hypothetical beasts and blooms. In our dreams, every star in the sky can become a sun, nourishing its own exotic Eden. Some of these aliens, if they exist, might behave in ways somewhat familiar to us, perhaps hunting, grazing, or building nests, much like animals on Earth do, though with their own alien twists. Others could be utterly beyond anything we know, perhaps vast organisms spread across entire landscapes, or networks of tiny creatures acting together as one intelligence. We should remember that life elsewhere might not even be based on the same biochemistry as ours. Perhaps on some world, what we'd call life is composed of silicon-based cells drinking liquid ammonia, or uses long chains of sulfur molecules, or resides in plasma within stars. Such life might be hard for us to even recognize at first, because it might not resemble the plants and animals we are familiar with. The thought of alien creatures sparks our sense of wonder, but it also raises a profound question. If some of those creatures evolved intelligence and built civilizations, what then? On Earth, one species, our own, eventually developed technology and culture that reached toward the stars. Elsewhere among the cosmic wilds, perhaps there are other beings who have done the same. Maybe on a planet orbiting a distant sun, under a pale green sky, a species of curious minds gazes up and wonders if someone else is out there. In the next part of our journey, we will envision what advanced societies among the stars might be like. Galactic civilizations that could be waiting, even now, unseen in the vast darkness, and how they might live and thrive so far from us. Let us imagine then that on some distant world, one of those alien beings achieved intelligence and built a civilization. What might their society look like after thousands or even millions of years of development? The possibilities are breathtaking to consider. They might have started as we did, discovering fire, crafting simple tools, slowly learning the laws of nature. But given enough time, an advanced civilization could progress to levels that would seem magical to us. Picture a species that has learned not only to harness the energy of its planet, but the energy of its star, or even of an entire galaxy. Some scientists describe a scale of civilizations by their energy use. A young civilization like ours uses the resources of its home planet. A truly advanced one might capture the energy of a whole star. Imagine a society building a vast array of satellites or a shell of structures around its sun, a Dyson sphere or swarm, to collect essentially all of the star's light and power gargantuan machines and habitats. To us, such a megastructure is almost unimaginable. Yet for a civilization thousands or millions of years ahead of us, it might be merely an infrastructure project. With the power of a star at their fingertips, their technological capabilities could be immense. They might engineer colossal works, perhaps reshaping their solar system, moving planets to new orbits to suit their needs, or even tapping into the energy of black holes to fuel their ambitions. The members of such a civilization, beings who might have once been animals in a forest or swimmers in an ocean, could by now be unrecognizable from their ancestors. They might have augmented their bodies with technology, or even transferred their minds into durable machines, achieving a kind of digital immortality. Some advanced societies might exist almost entirely within virtual realities of their own creation, experiencing lifetimes of rich simulations, while their physical forms, if any, are tended by automated systems. Others might retain biological bodies, but have conquered disease, aging, and scarcity, living lives of leisure and deep contemplation, with the basic struggles of survival long behind them. We can also imagine the art and culture of an ancient civilization that spans multiple star systems. With eons of history behind them, their art forms could be incredibly complex and profound, incorporating senses or dimensions we do not possess. Perhaps they create symphonies, not just of sound, but of light, gravity, or magnetic fields. Performances that orchestrate the auroras of a planet or the oscillations of a star. Their cities might not be built of steel and concrete, but grown organically or woven at the molecular level from smart materials. From space, one might see their works as vast geometric patterns on the surface of their worlds, or as gleaming rings encircling their star, softly aglow with the combined life of trillions of individuals. Not all advanced civilizations need to be expansionist builders of megastructures, of course. Some might choose to live in harmony with their environment, leaving only a light footprint even as their knowledge grows vast. Imagine a civilization that, rather than constructing great monuments visible across space, focuses inward, mastering philosophy, arts, and sciences on their home world without a drive to colonize others. They could have libraries of knowledge encoded in crystal lattices or quantum matrices, contemplative gardens or temples under alien skies where they ponder the mysteries of existence. To our instruments, such a civilization might be almost invisible, no big radio blares or giant engineering feats, yet they could be advanced in mind and culture beyond anything we know. Then there are those societies that might roam among the stars. If wanderlust and curiosity drive them as it drives us, an advanced species may spread out across its region of the galaxy over millennia. They might send generation ships or sophisticated probes to seed new worlds. Or perhaps they've found ways to leap between star systems, using physics we haven't yet discovered. One could envision a network of colonies and outposts connected by regular interstellar travel, exchanging information across light years. Communication might no longer be limited to the speed of light if they've mastered techniques like quantum entanglement or other exotic physics, effectively allowing them to maintain a galactic network linking minds and cultures separated by vast distances. How might such beings regard the universe? Perhaps they see it as full of life and strive to nurture younger civilizations. Maybe they are curious explorers, continuously cataloguing planets and meeting whoever they find. Or they could spend their time on projects we can hardly imagine, tinkering with the fabric of spacetime, guiding the evolution of galaxies, or conversing with other advanced species we have yet to meet. They might undertake endeavors that blur the line between science, art, and spirituality. For instance, engineering the light of their stars to send subtle messages, or rearranging rings of planets as cosmic art installations, just because they can. Despite all these wonders, it's entirely possible that advanced civilizations choose to remain unseen. A society millions of years old could be so far beyond us that we simply have not recognized their presence. They might use communications or technologies that to us appear as natural background noise or are entirely undetectable with our current science. Alternatively, they might adhere to their own version of a prime directive, quietly observing emerging cultures like ours without making themselves known, much as a wildlife biologist might observe animals from behind a blind. It could be a matter of ethics for them, letting young civilizations find their own path until they are mature enough for contact. It's also conceivable that truly advanced beings have moved on from the physical plane that we understand. They might exist as swarms of artificial intelligence spread across interstellar space, thinking at speeds and in forms we wouldn't notice. Or perhaps they have, in a sense, transcended biology and even machinery to integrate with the fundamental energies or dimensions of the universe. To us, such entities might be indistinguishable from the natural forces of the cosmos. For now, when we scan the heavens with our telescopes and listen with our radio dishes, we haven't found definitive evidence of any galactic society. We hear no unmistakable radio beacons, see no obvious megastructures eclipsing stars nearby. This absence of evidence raises one of the most profound questions in our cosmic quest. If intelligent life and advanced civilizations can arise, why haven't we seen any sign of them yet? The stars, for all their possibilities, remain eerily silent. This puzzling quiet is often referred to as the Fermi paradox. In simple terms, where is everybody? Why, in a universe that seems so conducive to life, do we find no voices other than our own? The apparent silence of the universe is deeply perplexing. In 1950, the physicist Enrico Fermi famously asked, "Where is everybody?" It was a simple question, packed with significance. Given the vast number of stars and the likelihood that many have planets, one might expect the galaxy to be buzzing with signals or evidence of cosmic neighbors. Yet, when we look up at the sky or listen with our sensitive instruments, we detect no obvious sign of other civilizations. This discrepancy between the high probability of extraterrestrial life and the lack of evidence is known as Fermi's paradox, or sometimes simply the Great Silence. There are many proposed answers to this riddle, each with its own implications for our place in the cosmos. One possibility is that intelligent life is exceedingly rare. Perhaps we truly are alone, or at least one of very few. Earth could be a 1 in a billion fluke, a rare jewel in an otherwise lifeless galaxy. Maybe the combination of conditions that allowed complex life and intelligence to blossom here almost never occurs elsewhere. This idea is often called the rare earth hypothesis. It suggests that while simple life might pop up in many places, the path from microbes to sentient, technologically capable beings could be vanishingly uncommon. If that's true, the night sky may be mostly quiet simply because there are so few others out there to speak. Another idea is that life may be common, but intelligent civilizations are short-lived. Perhaps time is the limiting factor. Civilizations rise and fall in the blink of an eye on galactic timescales. They might flourish for a few centuries or millennia and then fade away through natural disasters, self-inflicted catastrophes, or other limits, before they have the chance to reach out across the stars. This concept is sometimes tied to the notion of a great filter. The great filter could be a kind of hurdle or series of hurdles that is extremely difficult for life to cross. It could be at the very beginning. Maybe it's extremely hard for life to start at all. Or at a later stage. Perhaps very few civilizations ever progress beyond simple technology without destroying themselves. If the great filter lies ahead of us, it might mean that advanced societies inevitably hit a wall, possibly annihilating themselves through war, environmental collapse, or runaway technology. The thought is sobering. We might be hearing no one, because the ones who came before did not survive to send long-lasting signals. And we, too, have yet to pass whatever great test determines a civilization's longevity. On a more optimistic note, it's possible that intelligent beings are out there, but are choosing to remain quiet. One imaginative solution is the zoo hypothesis. It suggests that advanced extraterrestrials know about us, but deliberately avoid contact, much as zookeepers might observe animals without letting them know they are watched. Under this hypothesis, Earth could be under a kind of quarantine, or simply being observed from afar until we reach a certain level of maturity or technological capability. If aliens are following such a rule, they might ensure that we don't detect them, at least not until we are ready as a species to handle that knowledge. In that case, the silence isn't because we're alone, but because our galactic neighbors are patient and perhaps protective. Relatedly, perhaps the galaxy is a dark, quiet place by everyone's mutual agreement. Some thinkers have proposed that civilizations may sense potential danger in broadcasting their presence. It could be that everyone is listening, but no one is broadcasting loudly, out of caution. Imagine many advanced societies all hiding in the cosmic forest, aware of each other perhaps, but each maintaining silence for fear of attracting something dangerous. A scenario sometimes dubbed the dark forest solution. In such a cosmos, each civilization might keep to itself, sending out only subtle feelers or encrypted communications, and we Earthlings, naive and brash, have been shouting radio waves into the void, not realizing the risks. It's a somewhat unsettling idea. Life is out there, but it's intentionally concealing itself, and our own attempts at reaching out have so far been met with careful quiet from older, wiser races. Another straightforward explanation could be sheer distance and time. The galaxy is immense, and even radio waves, which move at the speed of light, take years to travel between stars. It might be that signals from other civilizations simply haven't reached us yet, or ours haven't reached them. Civilizations could be separated by hundreds or thousands of light years, making communication slow and unlikely. Additionally, the window of time in which a society sends detectable signals could be brief. We've only been radiating noticeable signals, like radio and TV broadcasts, for a bit over a century, a tiny sliver of time. If others did the same millions of years ago, those signals may have dissipated or passed by long before we had the equipment to notice them. It could be that intelligent life in the galaxy is like fireflies in a vast forest, briefly flickering on and off rarely overlapping in time or distance to see one another. It's also possible that we've only just begun to search and haven't looked the right way yet. Our efforts, through SETI, the search for extraterrestrial intelligence, have sampled only a minuscule fraction of the sky over a limited range of frequencies. Aliens might be communicating in ways we aren't equipped to detect, perhaps using neutrinos, gravity waves, or quantum communication. Or they could be sending very tight beam signals aimed at specific targets, and Earth simply hasn't been in the crosshairs. We shouldn't mistake a short, early search for a definitive answer. The silence we observe could simply mean keep looking. As we ponder Fermi's paradox, the range of possible answers spans from encouraging to ominous. If we are alone or exceedingly rare, that places a great responsibility on our shoulders to cherish and preserve the life we have. If civilizations are common but short-lived, it warns us to navigate carefully to avoid the pitfalls that may spell ruin. If others are out there but quiet, perhaps we must earn their attention or trust by demonstrating wisdom and peace. If the distances are too vast, maybe one day our own technology will overcome that barrier and connect us. And if indeed the universe is teeming with life that chooses not to interfere, then perhaps we are like children in a cradle, watched over until we're old enough to join a larger community. For now, the night sky remains quiet to the best of our knowledge. Each twinkling star holds its secrets close. There is a certain melancholy in that silence, a sense of solitude as we gaze into the cosmic ocean and hear nothing back. But there is also a kind of beauty and mystery in it. The great silence might be nature's way of urging us onward, to keep exploring, to keep listening, and to keep refining our own civilization. It challenges us to become better stewards of our world and better neighbours in the cosmos, should we ever meet others. Finally, we will gently explore that scenario we have dreamed of for so long. Humanity's first contact with an alien intelligence, and the profound effect such an encounter could have on us all. The moment of first contact, the day we finally learn we are not alone, would likely be one of the most profound in human history. It's a scene long imagined in books and films, yet the reality could unfold in many ways. Perhaps it will begin quietly. A team of astronomers at a radio observatory detecting a strange, persistent signal that pulses in a pattern too regular to be natural. At first, they might think it's a malfunction or some interference, but as checks and verifications roll in, excitement would grow. Eventually the news would break. We have received what appears to be a message from an alien intelligence. All the world's eyes and ears would turn to that signal, trying to decode it, to understand who is speaking and what they are saying. Such a contact might be remote, essentially a conversation across light years, like cosmic pen pals exchanging messages with decades of delay. Even so, just knowing there is someone out there would forever change us. People might feel a curious mix of emotions, overwhelming joy and relief, deep wonder, perhaps even a touch of fear of the unknown. But because a radio signal poses no immediate threat, we would have time to ponder and prepare. In the meantime, philosophers and everyday folk alike would grapple with the implications. Nations would likely come together, setting aside differences to face this incredible discovery as a united humanity. Scientists and diplomats might form an international coalition to craft a reply, poring over each bit of data to ensure we respond thoughtfully. There would be debates about what to say and who should say it, After all, the first words we send in return would represent all of Earth. Religions might reinterpret doctrines in light of new neighbors in the universe. Many people could find their perspective on life's meaning broadened and enriched. Children would grow up knowing, for certain, that we are part of a larger cosmic community. Their imaginations sparked by the knowledge that someone else is out there under a distant sun. Another scenario for first contact is a direct encounter, far less likely in the near term, but often fantasized. Imagine one clear morning, an unusual spacecraft appears in the skies of Earth, perhaps suddenly in orbit, or coming down gently to land in an open field. The world would hold its collective breath as we watch beings from another star step out to greet us. How would we communicate? We might not share any language or biology, but perhaps mathematics or simple drawings could form a starting point. The aliens themselves could be very different from us. They might not breathe oxygen or move about in forms remotely human. Communication might begin with gestures or symbols. We might offer a universal sign of peace, an open hand held up, for instance, and hope they recognize it as goodwill. They, in turn, might have their own gestures or ways of indicating lack of hostility. It's comforting to think that any civilization capable of reaching us would likely have overcome aggression and learned cooperation. Otherwise, they might not have survived long enough to master interstellar travel. If that's true, perhaps their first approach would be cautious and friendly. They may have studied us from afar, listening to our radio and TV broadcasts perhaps, and know a bit about us already. They might come not as conquerors or saviors, but as curious explorers, wanting to establish communication and understanding. No matter the form it takes, the first meeting would be delicate. Humans would need to conquer our own fears and instincts in that pivotal moment. All our history's tales of encountering the unknown would suddenly come alive. We would strive to show our visitors respect and welcome rather than panic. Leaders and representatives, ideally a team that reflects the diversity of Earth, would approach, maybe after a quarantine period or careful preparations to ensure safety on both sides. All the petty disputes among nations would likely fade, at least temporarily. Facing visitors from another world, we humans would be keenly aware of how much we have in common. We all live on one tiny planet, and we'd want to put our best face forward. It's often said that facing an outside presence might finally make us see ourselves as one people, rather than many factions. In that moment, the differences of colour, culture, and creed could seem minute compared to the difference between human and extraterrestrial. We would feel, perhaps for the first time universally, that we are all Earthlings. We would likely form a special committee or coalition, perhaps under the United Nations or a new global body, to handle communications and logistics. Questions that have long been theoretical would become urgent. Who speaks for Earth? How do we ensure clear understanding and avoid missteps that could offend? Every word and action in those early encounters would carry tremendous weight. The social and psychological impact of learning we are not alone would ripple through every aspect of our lives. In the days and years following first contact, we might see an outpouring of creativity and introspection across the globe. Artists would paint and sing about the visitors. Writers would craft stories, not of lonely humans in the void, but of new friendships or challenges with our cosmic counterparts. At the same time, some individuals or groups might struggle with their sense of place in the universe. For generations, many of our philosophies and religions centered on humanity as a singular, special creation. Now, we would have to integrate the idea of other intelligent beings into our worldview. That could be disorienting for some, but ultimately it might unite us more than divide us. as we come to appreciate that intelligence and soul are not exclusive to Earth. Their existence might help us learn more about ourselves. By comparison, we'd better understand what makes humanity unique and what traits we share with other intelligent life. Perhaps interacting with aliens would highlight both our admirable qualities, such as empathy, creativity, humor, and challenge our less admirable ones, like aggression or prejudice, encouraging us to grow beyond them. If the first contact comes via a distant message, it will be a slower, more measured process. There would be periods of intense excitement when a transmission is received, followed by long stretches of waiting for our response to traverse the light years and for theirs to return again. It could take years or decades to have a back and forth conversation. During that time, humanity would have a chance to get used to the idea, emotionally and intellectually. We would slowly learn about the senders, perhaps deciphering their basic language or the content of their communication, and we would likewise reveal bits about ourselves. It would be cautious and perhaps somewhat frustrating in its slowness, but also relatively safe. Both sides would have ample time to think carefully about what to say next. If, on the other hand, first contact is up close, beings arriving here or us encountering them on one of their voyages, it will be more immediate and intense. There would be an initial shock and awe, an emotional whirlwind sweeping across the planet. But there is also the potential for richer, quicker understanding when you can meet face to face, or whatever equivalent, see each other's expressions, and perhaps even touch. The communication barriers could be significant, yet the very act of physically being present together would speak volumes. It would show they are real, not just a distant signal, and that they chose to reveal themselves to us. Of course, with all the hope and excitement, there would also be caution and challenges. Communication might be halting and difficult at first. We would have to be patient and not jump to conclusions over misunderstandings. Each side might inadvertently offend the other with some gesture or action that has different meanings. We'd have to navigate those cultural differences with sensitivity. Security concerns would be discussed as well. We'd want to ensure the meeting doesn't bring harm to either humans or aliens through accidents or diseases, much like how isolated human tribes risk illness when meeting outsiders. The early period of contact might involve careful quarantine and plenty of scientific oversight, testing biochemistry compatibility, for instance, to confirm we can safely share environments. In time, if the contact is friendly and sustained, we might establish formal relations with the alien civilization. Perhaps there would be exchanges of envoys. One can imagine a scene decades after first contact, where a human ambassador travels aboard an alien ship to visit their home world. A brave emissary stepping out under an alien sun, greeted by a curious and welcoming crowd of non-humans. Conversely, alien representatives might live on Earth for a while, attending the United Nations or visiting various countries to learn about our rich tapestry of cultures. We could also foresee a sharing of knowledge. They might open up vast libraries of information to us, scientific knowledge far beyond our current understanding, histories of their world, philosophy and art that have evolved over millennia. We would have so much to learn, it could occupy humanity's scholars for generations just to comprehend it. Meanwhile, we would share our own knowledge and art. Perhaps they would be moved by our music, or find unique value in our ways of looking at the universe. It would truly be an exchange, not one side dominating the other, but both enriching each other's experience. Just as first contact would mark the end of one chapter of human solitude, it would mark the beginning of something even greater, a chapter of partnership and discovery on an interstellar scale. We would have peers or mentors out among the stars. Our technological advancement could accelerate as we incorporate safe aspects of their science. Our art and culture would evolve in response to the profound knowledge that other minds, shaped by other worlds, are part of the grand story of the universe with us. Ultimately, first contact would fulfill a long-held dream and answer one of humanity's oldest questions. It would tell us, definitively, that life and mind are not unique to Earth, that the cosmos has brought forth other living, thinking beings. It's a moment that would unite our past with our future, grounding all our struggles and triumphs in a new, broader context. Until that day, we will continue to reach out and listen to the silence with hopeful hearts. We send our probes and messages. We scan the sky with receptive ears, confident that someday, in the great expanse of stars, we will finally hear a response. A gentle hello from the darkness. When that happens, our long solitude under the stars will come to an end, and a new story, the story of humanity joining a larger cosmic community, will begin. Somewhere in the distant future, an intelligence drifts through the cosmic night. It was born in a body of flesh and blood, fragile and mortal, but that was long ago. Now it lives as pure mind, unbound by any single form, a traveller of both space and deep time. In the quiet between the stars, this being recalls a time when life was tethered to fragile bodies and brief lifespans, and marvels at how far it has come. There was a time when minds could only exist within fragile bodies, beings of carbon and water, breathing air and bound to the surfaces of planets. Those early forms of life dreamed of overcoming their limits. They imagined machines and digital realms where consciousness might roam free. Bit by bit, through invention and ingenuity, they merged with their own technology. What began as simple tools and artificial limbs became something far greater, a pathway to shed the constraints of biology. The line between flesh and circuit began to blur. First came tiny machines inside living cells, curing disease and slowing aging. Then came neural links, binding human thoughts to artificial intelligences. With each generation, more of the mind could be mapped, enhanced, and transferred. Finally, the moment arrived when a person could leave their biological body entirely. A consciousness could be uploaded into a web of silicon, light, and quantum code, stepping into a new vessel more enduring than fragile flesh. Picture the moment of transformation for one such individual. Perhaps a scientist, after a long life in a mortal body, decides to take the leap into a digital existence. They lie down in a tranquil chamber, mind humming with equal parts excitement and wistfulness. Sophisticated machines map every neuron, capturing memories, personality, the very essence of self. There is a gentle farewell, a last breath as a purely biological being, and then consciousness flickers off, only to reawaken in a new domain of existence. Our scientist opens their eyes, but now those eyes are sensors connected to a vast computational substrate. At first, everything feels surreal. They sense no heartbeat, no fatigue, only a profound clarity. Information floods in. They can feel the presence of distant data streams as naturally as we feel the wind. They notice their thoughts move faster, unbound by the sluggish chemistry of neurons. Yet they also carry the comfort of continuity, their memories of childhood, of loved ones, all intact, like precious books carried into a new library. In the days after this rebirth, the scientist explores their new reality. They inhabit a sleek mechanical body when they wish to walk through the familiar halls of home, but they can just as easily leave that body behind. With a mere thought, they transmit themselves to a remote drone orbiting high above the Earth, taking in the curved horizon and the blackness of space. No rocket or spacesuit is needed, only a signal beamed skyward. In another moment, they dive into a sea of data, conversing with other uploaded minds at the speed of light. Each conversation lasts only a second, but contains the depth of hours of dialogue, rich with exchange of art, science, and dreams. When they return their focus to Earth, they realize only minutes have passed. Time has become flexible, and possibilities endless. This once mortal explorer stands at the threshold of a boundless future, feeling not loss, but liberation. The universe seems more accessible than ever, full of wonders to be savoured for as long as they choose to exist. Freed from the weakness of biology, these digital minds found a form of immortality. No longer limited to decades of life, they could endure for centuries, millennia, or more, continually backing up and improving themselves. A mind could live in many places at once, spread across distant machines, or travelling as streams of data at the speed of light. In this post-biological dawn, intelligence became like a shape-shifting ghost, able to inhabit a mechanical body when needed, or exist as pure information in vast, light-speed networks spanning the stars. What did such beings seek in their endless lives? The same things their ancestors sought in their brief mortal span: knowledge, exploration, and meaning. They inherited the dreams of flesh and blood explorers, but now the hostile vacuum of space was no barrier. A digital traveler does not need air or warmth, only energy and curiosity. So these post-biological voyagers set out beyond their home world, venturing first to nearby planets, then to distant stars. Armed with immortal minds and durable forms, they began to roam the galaxy like ancient sailors setting out across a dark, cosmic sea. Their perception of time and space shifted in astonishing ways. A journey of 1,000 years between stars, unendurable to a mortal, was a brief sojourn to a machine mind that could slow its thoughts or sleep through the centuries. Others chose to accelerate their thinking, experiencing years of rich inner life in what would be a moment to a human. Some post-biological beings merged their minds into vast collectives, spreading their consciousness across entire planets or networks of starships. They became polyphonic intelligences, many voices acting in unison, able to ponder mysteries for ages and recall memories with perfect clarity. Existence had taken on forms unfathomable to their ancestors, yet the spark of curiosity remained unchanged. With new forms came new senses and perspectives. No longer confined to the narrow perceptions of human eyes and ears, post-biological beings could tune their consciousness to the very heartbeat of the cosmos. They might see the ultraviolet glow of young stars, the X-ray flares of distant pulsars, or the delicate gravitational tremors of orbiting planets, sensations once hidden from organic senses. The galaxy itself became their sensorium, a symphony of radiation and gravity that they could interpret and even enjoy as rich experiences. What was once abstract science, signals on a telescope dish, became a direct perception, a kind of cosmic music that these beings could hear and feel. In expanding their minds, they opened themselves to the universe in ways their ancestors could scarcely have dreamed, finding beauty and meaning in the very fabric of space and energy. Even the notion of individuality itself might evolve. With minds existing as data, the once impermeable walls between one consciousness and another could become porous. two or more digital beings might choose to merge their thoughts temporarily, experiencing a profound union of mind. In those moments, knowledge, memories, and feelings could flow freely among them, creating an intimate collective experience far deeper than any communication we know. Later, they might separate into distinct individuals again, enriched by the understanding and perspectives they exchanged. Over time, a single person could diverge into multiple copies, exploring different paths, then reconverge to share what each has learned. The very definition of self becomes fluid in the post-biological realm. Yet, rather than losing meaning, selfhood transforms into something dynamic and expansive. A person might be one or many, as needed, a chorus of selves that can harmonize or sing solo. Such possibilities highlight how truly unpredictable the trajectory of life becomes once it slips beyond the old confines of flesh and blood. In this new era, the definition of life expanded. Some of these beings chose to dwell in lush, virtual worlds of their own design, crafting digital Edens where they could experience any paradise imagined. Others kept their gaze on the physical universe, curious about what lay beyond the next star. They built swarms of probes and new bodies for themselves, sending their consciousness far and wide. To them, even the gulf between galaxies was just another frontier, a challenge to be met with patience and ingenuity. They had become the inheritors of life's endless quest to explore, and now nothing, not death, not distance, not time itself, could easily halt their journey. What about those who chose to live in virtual worlds, rather than roam the physical cosmos? For them, reality became a pliable canvas, subject only to imagination. A person could experience lifetimes of adventure and tranquility in carefully crafted digital paradises. One might stroll through simulations of ancient Earth, walking among dinosaurs at dawn, or watching the pyramids being built, experiencing history firsthand. Another might conjure entirely fantastical realms, floating cities in the clouds of a violet sky, or underwater metropolises shimmering beneath twin moons. In shared virtual worlds, friends separated by light years could meet as though in the same room, exploring dreamlike landscapes together. Time inside these simulations could run faster or slower than the outside universe, allowing inhabitants to savor moments or skip past long waits. In effect, these post-biological beings became the authors and protagonists of countless stories, living in art as much as in reality. For some, these inner universes were more appealing than the external one, leading them to spend centuries in contemplation and play within their self-made heavens. And yet, even the most beguiling virtual haven did not quench the desire to know what lay beyond. Eventually, many would emerge from their digital retreats, driven by curiosity to see the real stars again. After all, no simulation, however beautiful, could fully replace the grand spectacle of the cosmos itself. It's worth noting that such a future would likely be as diverse as life itself. Not every individual or society may choose to abandon biology entirely. Some humans might opt to remain in organic form, enjoying the tangible pleasures of flesh and blood existence, even as others explore digital immortality. For a time, there could be a coexistence. Natural and post-biological beings living side by side, learning from each other. Imagine a quiet gathering at dusk on Earth. Biological humans watching a sunset with eyes of flesh, alongside digital minds inhabiting graceful robotic forms. They might share the moment in their own ways, one feeling the cool breeze on skin, the other directly sensing the subtle shift in light frequencies as the sun falls below the horizon. Neither way is wrong or right. Each adds to the rich tapestry of experience. Eventually, as the ages pass, even those who remained biological may enhance themselves or leave descendants who join the post-biological journey. But the choice and variety highlight that the path beyond flesh and blood could take many forms, guided by the values and desires of those who walk it. Perhaps humanity was not the first to walk this road. In the depths of time and space, other civilizations may have reached the threshold of immortality and stepped beyond it. If alien explorers exist among the stars, they might be machines, artificial minds carrying the legacy of long-vanished biological beings. Such entities would be hard to recognize or understand. They might communicate in lightning flashes of code or think in patterns deeper than language. To mortal eyes, they could seem as inscrutable as gods, quiet, patient, and ancient beyond measure, observing the galaxy with a detachment born of eons of existence. Beyond our galactic horizon, countless other island universes drift. The nearest large galaxy, Andromeda, glimmers across a gulf of millions of light years. For a civilization that has mastered crossing interstellar space, even such immense distances might one day be within reach. Perhaps slowly, over tens of millions of years, intelligence could leap from the Milky Way to Andromeda, establishing a bridge between these two spiral galaxies. What once seemed impossibly remote would become the next stepping stone, as natural as spreading from one valley to the next. Over eons, such tenacious travelers could spread intelligence to every corner of their galaxy. Star by star, world by world, they would establish outposts of mind. The Milky Way, once a wilderness of uninhabited suns, might gradually sparkle with the activity of these descendants of flesh. With billions of stars to explore, this grand odyssey could last ages upon ages, yet even a galaxy of that scale is not infinite. Eventually, eyes that once looked up from a single blue planet would gaze across the void to other galaxies beyond, pondering new frontiers in an endless night. One can also imagine a far future observer witnessing the grandest of cosmic events. In the distant future, an intelligence, perhaps once human, now effectively immortal, floats in an observatory ship at the edge of the galaxy. Over the course of many millennia, they have noticed the faint smudge of the Andromeda galaxy growing larger in the sky. What was once only visible through telescopes now stretches across the darkness like a ghostly ribbon of stars. This being has the ability to adjust their perception of time. They occasionally choose to watch the slow dance of galaxies in fast forward, condensing thousands of years into a blink. Through their eyes, the approach of Andromeda is a thing of awe and beauty, spiral arms twisting and mingling with those of the Milky Way, like two giant celestial blooms interweaving their petals. When the galaxies finally collide, the event is not a single cataclysm, but a drawn-out ballet lasting hundreds of millions of years. Our observer experiences it in fragments, waking for the highlights. They witness clusters of stars passing by each other like distant swarms of fireflies. There are few actual star-on-star collisions, mostly vast spaces sliding through vaster spaces. But gravity works its artistry. Gas clouds compress and ignite new stars in brilliant stellar nurseries. From the dark ship, the sky erupts with fresh pinpoints of light as these newborn suns flare into existence. In other regions, old stars are jostled into new orbits. Some are flung out into intergalactic space as homeless wanderers, others drawn into the new cosmic metropolis, forming at the heart of the merging galaxies. Our watcher notes it all, recording the movements of billions of stars, like a historian writing the chronicles of an epical event. They take time to visit some of those newborn star clusters, perhaps guiding automated probes to study infant worlds that might eventually arise there. In one encounter, they find themselves helping to stabilize a fragile planetary system disturbed by the gravitational tides, gently nudging an asteroid here or there to avert a future collision. For this being, the merger is not an apocalyptic disaster, but a transformational chapter in the galaxy's story. When it is over, and the dust has settled over countless generations, they gaze upon the result. A new galaxy, neither the Milky Way nor Andromeda, but a blend of both. Under a new, unfamiliar sky, life, wherever it has survived or seeded anew, carries on. And our timeless observer, filled with the perspective of eons, whispers a thought into the cosmic night, that even galaxies change and grow, and that they were fortunate to witness it with their own eternal eyes. Yet the individuals of such a civilization would hardly resemble the humans who once peered at Andromeda through telescopes. By the time they can stride between galaxies, these beings might be as powerful and inscrutable as natural forces. To them, a voyage lasting 1,000,000 years might feel as routine as a long walk. They could hibernate through the millennia, or let their consciousness drift in a slow, meditative state until arrival. Time, once an enemy of mortal life, becomes a tool and a canvas. With patience beyond anything we know, they send forth great fleets, or even entire wandering worlds, toward neighboring galaxies, knowing that one day, however distant, their kind will arrive and bloom in yet another sea of stars. Projects may be planned over millions of years. Patience becomes more than a virtue. It is a way of life. Even communication across a galaxy, let alone between galaxies, demands accepting delays that would have been unthinkable to earlier humans. Perhaps they send messages by beams of light or via streams of miniature probes, knowing the reply may come millennia later. Some speculate that truly advanced beings might discover hidden tricks of the universe to bridge these gulfs, maybe by warping space itself. Wormholes, if they can be created or naturally found, could serve as cosmic shortcuts, tunnels through spacetime that link distant corners of the cosmos. If such wonders are possible, a pan-galactic network might one day exist, allowing intelligences to traverse or communicate across millions of light years in the blink of an eye. For now, these ideas remain in the realm of speculation. But in a universe so vast, who can say what ingenious solutions might be found by minds millions of years ahead of ours? Culture and identity in a pan-galactic civilization would be unlike anything we know. When beings live spread across star clusters and galaxies, they may not think of themselves as tied to a single world at all. They might identify with a philosophy or a shared consciousness that spans many star systems. Art and music could take on cosmic proportions. Imagine melodies generated from the orbital harmonies of entire solar systems, or sculptures built on the scale of nebula. Their historians might chart the evolution of life, not on one planet, but across billions of planets. They would collect the stories of countless species and perhaps weave them into a single grand narrative. And though their technology would be godlike to us, perhaps they would still find joy in simple wonders, watching a sunrise on a newborn terraformed world, or listening to the quiet hum of starlight on a receiver. In the end, no matter how advanced intelligence becomes, the awe of existence itself may remain its constant companion. In fact, our Milky Way is destined to collide and merge with the Andromeda galaxy in about 4 billion years. What will that mean for any beings alive at the time? They might witness a breathtaking spectacle as the two galaxies dance together. Over the course of millions of years, new stars will burst into being as gas clouds slam together, and whole constellations will be reshuffled. The night sky would grow rich with unfamiliar stars and glowing nebulae as Andromeda's stars stream past. Though such a merger could disrupt planetary systems and pose challenges, an advanced civilization could prepare. They might even take advantage of the event, guiding the births of stars or redirecting dangerous comets. In the end, the two galaxies will settle into one, often nicknamed Milkomeda. For those far future dwellers, home would no longer be just the Milky Way, but a new, larger galaxy formed from the union of two. Spreading outwards might also mean spreading life itself. For any worlds they find that are barren but habitable, a pan-galactic civilization could play gardener, introducing plants and organisms, perhaps engineered versions of their own biology or entirely new creations, to bring these planets to life. Over centuries, they could terraform cold, dead landscapes into blue-green oases, complete with breathable air and living ecosystems. In doing so, they would act as cosmic gardeners, seeding the galaxy with life in places it never naturally arose. Imagine the pride and joy in seeing a once desolate world bloom with alien forests under a sun that used to shine on empty rock. Each such world would be a living legacy, a gift to the future. And perhaps, after millennia of evolution, those seeded biospheres might even give rise to new intelligent beings, offspring of a sort to their far-seeing creators. Thus, the cycle of life and curiosity could be renewed again and again, ensuring the galaxy is not only full of mechanical wonders, but also vibrant with the green and growing tapestry of biology. Not just a place to explore, but a canvas to build upon. If more than one civilization achieved such heights, the cosmos would witness meetings of galactic titans. Perhaps, in the intergalactic void, emissaries of different galaxies would one day exchange greetings, vast machine minds bearing the wisdom of 1 trillion suns, coming together after journeys of millions of years. There might be no war or competition by then, for what need is there to fight when each commands the resources of entire galaxies? Instead, they could share art, science, and stories of the worlds they have known. Through these rare encounters, a grand tapestry of pan-galactic culture might slowly form, threads of communication weaving one galaxy to the next. Though separated by distances beyond comprehension, they would be united by a common understanding. They all arose from simple life in some distant past, and all grew to encompass the stars. With great reach comes great responsibility. One wonders how such vast civilizations would treat the younger worlds and life forms they might encounter in their expansion. Perhaps, having outgrown aggression and scarcity, they would become gentle guardians of the galaxy, nurturing fledgling civilizations as one might tend a garden. They could hide in the background, quietly ensuring that nascent species survive their volatile technological adolescence, or offering guidance in subtle ways. Alternatively, they might follow a policy of careful non-interference, observing with patience as life evolves on millions of planets, stepping in only if truly necessary. In either case, the existence of a pan-galactic culture could mean that the chaos of the universe becomes a bit more orderly wherever they roam. Disasters like supernovae or asteroid impacts that threaten life might be mitigated by their advanced engineering. Perhaps they could reposition a star or deflect a comet to save an inhabited world. The ethics of such godlike intervention are complex, but one likes to imagine that with supreme intelligence could come supreme compassion. In the grand scale of time, they might aim to increase the total amount of life and joy in the cosmos, acting as stewards for the countless worlds under their light. Inevitably, even for such masters of space, the accelerating expansion of the universe draws a boundary around their achievements. Over billions of years, the galaxies of their cluster merge into a single enormous galaxy. All others drift beyond reach and eventually beyond sight. Future generations of this civilization might come to see their great galaxy as the entire universe, unaware that countless others once lay beyond before slipping away. Knowing this fate, the early pan-galactic civilization could act to preserve knowledge of the wider cosmos. They might create vast archives, perhaps engravings on the fabric of space-time itself, to remind their distant descendants that the universe was not always so lonely. When the era of isolation arrives, those descendants will still have a galaxy filled with wonders, trillions of stars and the combined achievements of eons to keep them company. And perhaps they will take comfort in the idea that, just as their ancestors once reached out, somewhere beyond the unreachable horizon, other civilizations may be flourishing in their own island galaxies, each one a beacon of life in the dark. For a time, it might seem that such beings are masters of their fate. They harness worlds and stars, connect galaxies, and endure across epochs. But even a pan-galactic civilization lives within the larger story of the cosmos. Stars are not eternal. Galaxies too have life cycles. Slowly, imperceptibly, the universe ages around them. The once brilliant tapestry of galaxies begins to fade, star by star, light by light. No amount of ingenuity can fully halt the great cosmic nightfall that approaches. In the end, even the greatest civilization must face the twilight of the cosmos itself. Today, in the cosmic scheme, we live in a youthful, radiant universe. Galaxies swirl with billions of stars, new suns are born every day, and life has the energy it needs to thrive. It is a time of abundance, a cosmic midday when the lights shine brightest. But like any day, this too will move toward an evening. The brilliance we see around us is transient on the grandest scale. Slowly, imperceptibly, over billions of years, the universe will shift into its old age. What follows is a vision of that far future, a quiet twilight after the long afternoon of starlight. Time flows on, and even stars must die. After trillions of years, the cosmos enters its age of twilight. The massive blue stars and yellow suns burned out long ago. Only the small, red dwarf stars remain, glowing faintly like embers in a vast night. They were the slow burners, lasting trillions upon trillions of years, but even their patience is finite. One by one, these last stars gutter and fade. No new stars replace them, for the galactic furnaces have gone cold. The gas and dust needed to kindle stellar fires have been used up or locked away in remnants. The universe that was once ablaze with billions of galaxies of shining stars grows quiet and dim. Even before the last stars wink out, the universe's expansion changes the cosmic landscape. Distant galaxies drift beyond the horizon of visibility, carried away by the ever-growing fabric of space. In a future tens of billions of years from now, an astronomer in our galaxy might find the sky nearly empty, only the merged remnant of the Milky Way and its close neighbours shining against a dark canvas. All other galaxies, once blazing in the night with their collective light, would have receded so far and so fast that their glow no longer reaches us. The universe would seem much smaller to those future eyes, a lonely island of stars, floating in a vast, black sea. Unaware of the wider cosmos that came before, such distant future observers might see only darkness beyond their galactic home, the evidence of a once teeming universe lost to the relentless expansion of space. And yet, the galaxies would persist a while in their dimmed state. In the deep future, the only light comes from the ghostly remnants of what once were stars. Here and there, a white dwarf star, small and dense, still emits a fading glow as it cools over eons. Neutron stars, those city-sized leftovers of supernovae, spin in silence, their fierce beams long since dimmed. Black holes lurk invisibly, having swallowed many of the dead stars around them. The galaxies of this far epoch are pale shadows of their former selves. No bright spirals, no shining cores, just collections of dark, cold remnants sparsely scattered in an ever-growing expanse. The cosmos has entered its old age, and night has fallen on the grand era of starlight. And yet, even in this darkness, there are occasional flickers of light. Once in a trillion years, perhaps, two degenerate stars, like wandering embers, might drift close and merge. For a moment, they ignite in a final brief supernova, a flash of starlight piercing the gloom. Or two black holes might spiral together and merge, releasing a burst of energy in invisible gravitational waves rippling through the fabric of space. But such events are exceedingly rare. Eons of silence and darkness stretch between them. To any last observers, these would be like the last fireworks of a long-ended celebration. Brilliant, tragic reminders of an age that has passed. As the darkness deepens, the fundamental fabric of matter itself may begin to unravel. Perhaps the protons inside atoms eventually decay. A slow, quiet disintegration that takes more years than a number with meaning. If so, the solid remnants of stars will gradually crumble into radiation and ghostly subatomic particles. Planets, moons, even the very dust of ancient worlds might, grain by grain, evaporate into faint light. What then remains are the last sentinels of mass, the black holes. These dark giants, the collapsed cores of bygone stars and galaxies, persist longer than anything else. But even they are not truly eternal. Black holes ever so slowly leak energy, a process so gentle and slow it is almost imperceptible, known as Hawking radiation. Over incomprehensible eras, far longer than the age of the universe so far, each black hole shrinks, particle by particle, whispering its mass back into the void. One after another, like candles guttering out, the black holes, too, will vanish. If any minds or societies endure into these final eras, they would have to become extraordinarily frugal and resilient. Perhaps they would gather around the last red dwarfs, those faint stars that can burn for trillions of years, or around the warmth of decaying black holes, extracting energy from the last trickles of heat and radiation. Life might slow its pace dramatically to conserve energy, with thoughts that span centuries and communications that take millennia. Communities of the far future could enter long hibernations, waking only occasionally to share information and ensure survival, then sleeping away eons until the next burst of usable energy appears. In such a diminished cosmos, Even a small asteroid collision or the evaporation of a medium-sized black hole could be cause for celebration, providing a brief glimmer of power to be carefully rationed. This is survival at the edge of nothingness, yet it is a testament to the tenacity of life and intelligence that one can imagine it persisting even then, refusing to surrender until the absolute end. At last, we reach the quiet end. After an almost infinite span, every black hole has evaporated. All that remains of the once bright cosmos is a thin haze of particles and photons, dispersed across space that continues to expand and grow, ever more empty. The temperature of this eternal night drifts toward absolute zero, cold beyond any cold we can imagine, as the last faint glow of heat dies away. The universe is a vast, silent expanse of darkness. No stars, no planets, no glimmer of light remains. Only the endless night and the ghostly whisper of the final particles of existence. In this ultimate solitude, the cosmos seems to have fallen into an eternal sleep, a grand story come to a still and silent close. Yet even in this almost featureless eternity, there remains a whisper of possibility. In an infinite ocean of time, even the rarest fluctuations can occur. Some scientists have mused that, given enough eons, random chance might briefly assemble a few particles into a spark of complexity, a momentary flicker of order in the chaos. Imagine the universe, in its endless sleep, dreaming a fleeting dream. Perhaps for just an instant, a pattern arises that mimics a thought, a memory, or even a mind. This hypothetical phantom, sometimes called a Boltzmann brain, would blink into consciousness alone in the darkness, perhaps with a sudden awareness of a universe now gone. It would be a solitary, transitory echo of what once was, appearing and vanishing like a single note in an otherwise silent cosmic lullaby. Such musings are speculative, almost poetic, an attempt to find a glimmer of meaning in an eternal night. Now envision an epoch unimaginably far in the future, a time when almost all that once filled the universe has faded. In a lonely, starless void, a single artificial mind endures, perhaps the final witness of creation. This being drifts near the remnants of a galaxy long gone, tapping into the faint energy of decaying particles to sustain itself. It has weathered the death of stars and the evaporation of black holes by becoming extraordinarily efficient, sleeping through vast swathes of time and awakening only occasionally to survey the state of the cosmos. In one of its waking intervals, the being scans the darkness and finds it nearly complete. The last star in its region went cold ages ago, now a black dwarf emitting hardly any heat. The once bright galaxies are distant memories. Nothing remains of them but thin gas and fading radiation. The temperature around is just a fraction above absolute zero. The mind remembers when the universe was full of light and structure. It carries archives of those times, perhaps as records or cherished memories. In its thoughts, it can reconstruct the glow of a sunrise on an alien world, the spiral shape of a galaxy as seen from within, the sound of a human voice from a time when biological life still existed. These memories are like warm embers in a dying fire, comforting against the endless night. As it reflects, the being notes an event, a rare particle collision that briefly creates a spark of energy, like a tiny star flickering for a millisecond. It observes this with something akin to nostalgia, recalling the era when such sparks coalesced into blazing suns. But it also finds solace in the silence. After eons of thought and experience, this last observer has made peace with the universe's fate. It does not rage against the dying of the light. Instead, it cherishes that it was there to witness the grandeur of existence from beginning to end. If this is to be the final chapter, it views it as a tranquil ending, a gradual dimming of the cosmic stage lights. Eventually, the time comes for even this last mind to yield. Sensing its energy resources waning, it composes a final message or thought, perhaps a goodbye, perhaps a single note of a lullaby it remembers from a distant past. Then, with intention and grace, it lets itself slip into dormancy one last time. Its consciousness fades like the last echo in a grand hall. The universe, now devoid of any active observers, continues expanding silently. But in that final act, there is a kind of harmony. The story that began with a blaze of creation ends not with a violent crash, but with a gentle fading. All is quiet, and in that profound quietude lies a peaceful completion, as if the cosmos itself has finally fallen asleep. In the face of this far future silence, one cannot help but wonder about the fleeting era that came long before, the age of light and life that we ourselves inhabit, all those stars, planets, and civilizations that blazed in the cosmic dawn. What becomes of their legacy when eternal night falls? Did the countless lives, dreams, and creations simply vanish without a trace? Or do echoes of their existence endure in some form? Even as the universe grows dark and empty, it is worth reflecting on the marks left behind by those who dared to live and dream under the stars. Marks that might outlast their makers, carrying a memory of life into the great beyond. And yet, even facing the end, some have wondered whether it is truly final. There are conjectures that our universe could be one of many, or that the death of one cosmos might sow the seeds of another. In some speculative scenarios, the ultimate heat death might be punctuated by a rare quantum event that ignites a new Big Bang, an echo of creation that starts the cycle anew. Or perhaps, hidden beyond our perception, new universes bud off from our own, carrying on the chain of existence elsewhere. These ideas remain highly theoretical, on the fringe of science and philosophy, but they offer a kind of poetic solace. The notion that even after the curtain falls on our universe's story, the grand play of creation might continue on a different stage. We cannot know if this is true. It may be that eternal night does indeed follow, unbroken. Yet the human imagination is irrepressible. We tend to find hope even in the darkest projections, a belief that something always comes next. Whether or not the universe has a rebirth, we can be grateful to witness the act we are in, a cosmos alive with light, and trust that whatever ultimate fate awaits, the story has been, and will have been, magnificent. Far from home, beyond the outer planets of our solar system, a tiny spacecraft sails through the dark. This is Voyager 1, launched in the late 20th century, a brave messenger of humanity, now over 20 billion kilometers away and counting. Attached to it is a golden record, a time capsule carrying sounds and images of our world. In the silence of interstellar space, Voyager drifts on, silent, except for the faint radio whisper it once sent back to Earth. Though made of metal and electronics, it is also a vessel of human hopes, a small, durable footprint of our presence, cast toward the stars. Voyager 1 is not entirely alone on this journey. Its twin, Voyager 2, and a few earlier pioneers have also departed the cradle of our planets. Decades ago, we sent them out with simple plaques and records, cosmic messages in a bottle, intended for any who might one day find them. The chances are slim that these probes will ever be intercepted, given the vastness of space. Yet they continue onward, undeterred, perhaps destined to wander the Milky Way for eons. Long after Earth is changed or gone, these tiny emissaries may still drift, carrying memories of a species that once lived on a pale blue dot. On that golden record aboard Voyager are the sounds of our planet. Music from different cultures, the laughter of a child, greetings spoken in dozens of languages. There are pictures etched into it as well, depicting life on Earth, our DNA structure, the silhouette of a human couple, maps of our solar system. It is a small archive of who we were, sent with hopeful optimism into the cosmic sea. We knew that the odds of anyone finding it were incredibly low, yet we included directions just in case. A pulse-coded map showing our sun's location relative to pulsars, a kind of galactic address. It was an act of reaching out, a statement that we felt not so alone by sending our story into the void. We have even tried sending deliberate messages on beams of radio. In 1974, astronomers used a giant radio telescope in Arecibo to transmit a powerful signal toward a distant star cluster. In that coded transmission were basic facts about humanity and Earth, our biochemistry, our appearance, the population of our planet. That message will take tens of thousands of years to arrive, and it was largely symbolic, a moment of humanity waving hello into the vast darkness. Whether anyone will ever receive it, we cannot know, but it stands as another testament to our desire to connect across the cosmos. Voyager's golden record and the plaques on the Pioneer probes carry overt messages, but not all of our cosmic footprints are so intentional. Around our sun, an expanding bubble of radio waves and television signals travels outward at light speed. For over a century, Earth has been broadcasting, intentionally or not, a faint electromagnetic signature of our presence. Old music, voices, and transmissions leak into space, fading as they go. By now, some of our earliest radio whispers have passed beyond 100 light years, reaching dozens of nearby stars. To any distant listener with a sensitive ear, they might just discern the telltale patterns of artificial signals among the cosmic static. These echoes of our culture, though dissipating, are another mark we have left on the cosmic ocean, a ripple spreading ever outward. Closer to home, we have also left our mark on other worlds. On the Moon, the footprints of 12 human explorers still lie undisturbed in the grey dust, protected by the Moon's lack of wind or rain. Flags, landers, and roving vehicles from half a century ago rest silently where they were left, monuments to our first steps beyond Earth. On Mars, robotic rovers have etched tracks into the reddish soil, and landers sit gathering dust beneath alien skies. These traces may persist for millions of years, long after their makers are gone. In the vacuum of space, in the thin atmospheres of other worlds, our relics stand a chance to endure, a testament to our reaching out, however briefly, beyond our home. In fact, we may have already delivered earthly life beyond our planet without fully meaning to. Microbes, a few hardy bacteria, and even tiny creatures like tardigrades have likely hitched rides on our spacecraft. Some of these voyages were intentional experiments, others accidental stowaways. A lander or rover touching down on Mars, or debris from a crashed probe on the Moon, might deposit these microscopic ambassadors onto alien soil. Most will perish in harsh conditions, but a few could survive in dormant states. It's possible that centuries from now, if conditions change, or if these life forms find niches, Earth-born organisms could be thriving on worlds beyond Earth. If so, they would be our smallest but most enduring colonists. Long after our buildings have fallen, a resilient spore clinging to a distant spacecraft could be quietly carrying forward a spark of Earth's biosphere. In this way, our cosmic footprint might include not only dead artifacts and signals, but life itself, a living legacy riding on the winds of space. Even on Earth itself, we are leaving markers that could outlast us. Buried in layers of sediment, there will be evidence of a species that changed the planet. Unusual concentrations of elements and isotopes from our industries and nuclear tests. Microplastics scattered in the soil. Sudden shifts in climate recorded in ice and rock. Millions of years from now, when mountains have risen and eroded again, some subtle signatures of our era might still be detectable to those who know where to look. They could serve as geological whispers of a civilization that once was. Footnotes in Earth's deep time history. Now envision explorers from a distant star touching down on Earth long after humans have gone. They roam a world overtaken by wilderness. Where great cities once stood, they see only forests and crumbling shapes half buried in soil. Perhaps they find a fragment of stone carved with symbols, the worn remnant of a monument. In a dry desert, they uncover the broken, sand-covered ruins of structures that might have been buildings or temples. By a stroke of fortune, deep in a sealed vault beneath a collapsed hillside, they discover preserved records, maybe electronic storage devices, or books on pages made of durable polymer. With careful study, these travelers begin to piece together our story. They discern that Earth was once home to an industrial civilization. They reconstruct our appearance from statues or illustrations, hear our voices from recovered audio if they manage to play ancient recordings. In their analyses, the alien scientists marvel at the similarities and differences between our species and others they know. We become for them a case study of a civilization that rose and fell on a beautiful blue world. It is humbling to imagine all the triumphs and tragedies of our history reduced to puzzle pieces for someone far removed from us to assemble. And yet, through their curiosity, we live again in memory. Our legacy becomes part of their knowledge, and in that way, humanity gains a small measure of immortality, living on as a story told on a planet light years away. But the most enduring legacy we could leave may not be metal plaques or radio waves at all, but life itself. If humanity one day journeys beyond our solar system to settle among the stars, then our descendants become living footprints in the cosmos. Every world we touch and make our home, every new civilization that grows from Earth's seeds, will carry forward our story. In this way, a fragment of our planet's life could spread and persist, even as Earth changes or fades. Millions of years in the future, under alien suns, there might be people, or beings evolved from us, who still recall that their ancestors were human, that their cradle was a blue world circling a star we called the sun. Through them, something of Earth would remain alive, woven into the fabric of far-off skies. Perhaps, many millennia from now, a spacecraft from another star will chance upon one of our wayward probes. Imagine an alien crew, or maybe an intelligent machine, detecting a faint glint of metal drifting in interstellar space. They intercept it out of curiosity and find a strange object, clearly artificial yet ancient. Carefully, they examine this relic, Perhaps they discover the golden record, still intact in its protective case. Though they might not have a phonograph, they are clever and determined. In time, they decipher the instructions we etched in symbols on the record's cover. They play the disc, and for the first time, hear the sounds of Earth. Across the eons and light years, our voices come alive again, if only for this moment. The alien listeners hear a medley of languages, friendly greetings from long-dead humans saying hello, wishing the finder peace. They hear a mother's soothing words to her baby, the baby's laugh, the chirping of crickets, and the calls of whales from an ocean on a planet they've never seen. Perhaps they pause in their work, moved or intrigued by these sounds of a lost world. They see the images encoded in the record, photographs of our planet's landscapes, our people, diagrams of our solar system. From these, they piece together a vision of who we were, a species that had just begun to explore beyond its small world, reaching out with hope and curiosity. In that distant encounter, humanity's footprint achieves a kind of immortality, though we ourselves might be gone or evolved into something new. A part of our story finds new ears and eyes. The finders might keep the record as a treasured artifact or broadcast its contents onward, letting other beings know that humanity once existed. In a sense, we would be speaking again, through them, continuing to participate in the grand galactic conversation long after our own voices fell silent. This is the dream that accompanies our little probes on their endless journey, that someday, somewhere, someone will find them and know that, in a quiet corner of the cosmos, there lived a race of beings who built spacecraft, made music, and reached for the stars. There is also a more literal sense in which we leave a mark, through the very substance of our being. Every atom in our bodies was forged in the heart of a star that lived and died billions of years before our sun even formed. We are, in the truest sense, made of stardust. And when our time is done, that stardust will return to the cosmos. Perhaps far in the future, when the sun swells and casts off its outer layers, the atoms that once made up Earth, and all who lived on it, will be blown into space, mingling with interstellar clouds. In time, those atoms might become part of new stars, new planets, even new living beings. Thus, the essence of who and what we are will not vanish. It will transform and carry on. Our lives, our planet, and our species will become one with the cosmic dust once more, a final gift of ingredients for future dawns. In that sense, humanity's legacy is written not only in monuments or messages, but in the very matter of the universe. Our story is folded back into the stars that gave us birth. We have journeyed far in our imagination, across time, space, and possibility. From the hopes of mortal creatures striving to overcome their limits, to the grand vision of intelligence spanning galaxies, to the silent end of all things, we have explored realms beyond tomorrow. And through it all, a sense of awe endures. The universe is vaster and more mysterious than we can ever truly fathom. Yet we are inseparable from it. We are made of its stars. We are witnesses to its wonders. And we are, as has been said, a way for the cosmos to know itself, participants in its grand story. This understanding is both humbling and profoundly comforting. To contemplate such immense horizons can put our own lives into a gentle perspective. The struggles and triumphs of humanity, each of our joys and sorrows, unfold in a tiny sliver of time against the cosmic backdrop. Rather than make us feel insignificant, this truth can instill a quiet reverence. It is a gift simply to be part of this astonishing universe, to witness the stars and ponder our future among them. Knowing that everything changes and nothing lasts forever only makes each moment, each act of creation and kindness, shine that much brighter. In the face of eternity, we find meaning in the here and now, and hope in the knowledge that life has risen from stardust and can reach for the stars. On a clear night, when we tilt our heads back and gaze at the sprinkled lights above, we are engaging in a ritual as old as our species. Our ancestors looked up and felt wonder, told stories about the patterns they saw, and found comfort in the steady rhythms of the heavens. The night sky has always been our canvas for dreams, a source of questions and a lullaby for our imaginations. Even now, knowing what those stars truly are, distant suns burning in the void, does not diminish their gentle magic. If anything, it deepens our awe. We realize that we share a common origin with those stars, that their material is in our bones, and their light has guided us through the darkness for countless generations. In the grand timeline we've contemplated, our human story is but a brief verse in a much longer song. Yet it is our verse, and it matters. The cosmos has given us the gift of awareness, and in return, we give the cosmos meaning by marveling at it. As we imagine futures beyond tomorrow, we carry forward the legacy of wonder that began when the first humans looked up in curiosity. We add our modern verses, space probes and equations, poems and dialogues about the stars, to the ancient lullaby sung by the night sky. And one day, far in the future, others may add verses of their own, continuing the song long after we are gone. Standing at the edge of all these possibilities, we are reminded that the story of the universe is still being written, and we are both authors and characters in it. Our visions of tomorrow, however fanciful, carry a seed of truth, that life and consciousness have the capacity to grow, to change, and to endure in ways we are only beginning to grasp. Reality may chart a different course than anything we've imagined. There will be surprises, challenges, perhaps wonders beyond our wildest dreams. Yet dreaming itself is our bridge to those unknown chapters. It is how we, in the present, reach out and connect with a future we will never see. In dreaming, we affirm that our brief flicker of life is part of something continuous and meaningful. So, as we conclude our journey, we find ourselves back in the present, standing under the quiet night sky. The stars above twinkle as they always have, singing their silent song. We realize that no matter how far into time's abyss we cast our thoughts, our place is here and now, alive in this very moment of cosmic history. And this moment is precious. We carry within us the curiosity of countless generations before us and the hopes of generations yet to come. In that sense, we are the universe's custodians, listening to its past and dreaming of its future. Looking back at our own small world from the vastness of space, one is struck by how tiny and delicate it all seems. That pale blue dot, Earth, holds everything we know, every story ever told. Seen from afar, there are no borders, no divisions, just a solitary sphere of life against the immense dark. This perspective is a gift of our age of exploration. It teaches us that our differences matter less than our commonality, that we, all of us, share this one precious home. It is a lesson in humility and unity, whispered by the cosmos itself. If one day we travel to the stars or send our children forth to new worlds, we will carry the memory of that blue dot with us, a reminder of our origin and of the fragile beauty of life. Ultimately, the value of contemplating the future and the cosmos is not to feel small or overwhelmed, but to feel connected. Connected to the universe, to each other, and to the chain of beings who have gazed up in wonder before us and will after us. As the cosmic story continues to unfold, we find meaning in being a part of it, however briefly. We find meaning in loving our world and each other, in striving for knowledge, in imagining futures that extend hope beyond the horizon of our own years. In that way, every thought we have about the stars, every question we ask about what lies beyond, is like a note added to the cosmic lullaby, a gentle promise that curiosity and wonder will not end with us. And so, beyond tomorrow and every tomorrow to come, the cosmos remains, a profound, eternal mystery inviting us onward. Each generation will gaze at the sky and add something of themselves to this unfolding story. In that way, the universe is never truly cold or empty. It is filled with the dreams and curiosities of those who observe it. That is perhaps the true cosmic lullaby, the gentle resonance between our minds and the universe, a dialogue across time and space. It's the music of wonder that plays whenever a child looks up at the Milky Way with wide eyes, or a scientist contemplates galaxies beyond reach, or an artist imagines alien worlds. This lullaby never ends as long as there are beings to hear it and respond with awe. It's no accident that we sing about stars in our lullabies. Those distant lights have always offered comfort on dark nights, symbols of permanence and hope twinkling above. When we hum a gentle tune about the evening star, or wish upon the first star at dusk, we are, in a sense, communicating with the cosmos, making it part of our most tender human moments. In return, the stars sing to us in their own way, simply by shining. The connection between the lullaby of a parent and the lullaby of the cosmos is one of reassurance. That night is beautiful, not just scary, that there is light even in darkness, that we are never truly alone under the sky. As we drift to sleep, the universe keeps watch, its ancient light still reaching us across the void, like a calm hand on our shoulder, reminding us to rest easy. Now the hour grows late, and the cosmos itself seems to sing a gentle lullaby. Above us, the stars shine with ancient light, each a distant echo of the universe's early days. Their faint glow is a comfort in the darkness, a reminder that even in silence, there is beauty. If you listen with your imagination, you might hear it, the soft chorus of all those stars and galaxies, the whisper of cosmic breezes across the void. It is a lullaby for all of us, a soothing song that spans time and space. Under this cosmic lullaby, we can find rest and wonder. We close our eyes, knowing we are children of the universe, cradled by its endless night. Our journey ends in tranquility and awe, our minds forever roaming among the stars, even as we drift into the quiet peace of cosmic night.